Never been colder in my life. I'm literally gonna freeze to death. Okay, let's do the homework first, because it's the most important thing. Get the most important things out of the way. This shit is terrible. You gonna add chess elo to your resume? Yeah, you can, bro. I just thought it was interesting. Let's see. This is my old resume. I haven't updated it since, I don't even know, January maybe. Where do I have chess elo? Yeah, here. Can't believe I got third. Bro, the thing is, I would have gotten first if I didn't get third. You know what I mean? Like the person that I lost to, I would have, if I beat them, I would have beat the first person for first place. Easily. So easily. But that was a long time ago. I aced the exams. Congrats, brother. That's fire. I hope you get a good score. Thank you, me too. Have a linear algebra final tomorrow? That's crazy, bro. Good luck. No way you started this early? Hi, by the way, what's up? Yeah, my class got out early today, so I was able to start the stream a little bit earlier. Could you play a Blitz game real quick? No. Maybe later when I take a break later, but I don't want to play right now, no. I gotta do my homework, that's why. What time is it for you? It's 11:11. Make a wish. Blitz, you mean chess? Yes, he does mean chess. I don't usually even play Blitz. I usually play Rapid. It's what I'm best at, but I can play Blitz as well. I'm only like a 1600 Blitz, so not that good. But you're like not even allowed to stream and play chess. Like you have to use like special stream configurations, otherwise you get banned for cheating. Like you can't look at chat. I don't even think you can have. You might have to have chat in like emote mode or something when you play. And you're not allowed to play on stream. What is your rating? We can go look at my ratings. Three friends? Is that a lot or no? Yeah, but Hikaru's Hikaru, dude. Like, what are they gonna accuse Hikaru of cheating against 1600s in Blitz? But he can't look at stream while, I don't even know. I don't know how it works. But you're supposed to do, like, I don't even know how it works. I'm gonna go to bed soon. Then study chemistry in the morning. Wish you luck. I'm wishing you luck, bro. And good luck to you. Thank you. Do you think you can help him with the 3 to 4 indoor hobbies? Warhammer. Do you think you can healthily maintain 3 to 4 indoor hobbies? I don't know, dude. I don't really have any indoor hobbies. I guess hockey's indoor. Does hockey count as an indoor hobby? 1700 pro? That's crazy. No way. What, 1700 elo in League or Valorant terms? Never played either of those games, so I wouldn't know. Good luck. June 14th, bro. Good luck. So you got a lot of time though, so that's good. All right, let me do the homework assignment. So we know that it should be frictionless, obviously, because friction is an external force. And to be reversible, we can't have external forces, right? You don't have control over them, so you can't replicate them. You can replicate them, but you don't have control over them, so your effectiveness in replicating them is going to be hindered. Okay, wait. I'm trying to find my lecture notes. You can catch me diving. Yeah, I need to lock in and put some music on. Oh, here's my equation sheet. And here's my lecture notes, right? Yeah. These aren't even my lecture notes. These are his lecture notes, but it's the same shit. Okay. So for a process to be reversible, so we looked at, this is usually cyclic. I forgot where this was in the lecture notes. We did cover this in lecture though. Maybe it was like the Carnot cycle or something. Or maybe with entropy and stuff. Oh yeah, reversible, isothermal. Yeah. Okay, so it is with the Carnot cycle. Okay. Okay. Shit is fucking terrible. I don't know why I keep drinking it. It's actually like not good at all. Okay, and this is like, where was entropy? Oh, entropy was over here. Okay, yeah. Entropy. Yeah, the change in entropy of a system during a reversible process. You know, just think about it. The system can be close to equilibrium. I think, okay, let's see. Any thermal interactions taking place in the process should occur across infinitesimal temperature or pressure gradients. So the change in temperature and the change in pressure. Oh, yeah. If it's going to be reversible. Oh, wait. I think so. Yeah. Because entropy equals, change in entropy equals delta Q over T. So you need to make sure that your delta Q and your T are very, very small. Like the changes are very, very small. So that you don't get a change in entropy, because any change in entropy will result in yeah, okay. This is all entropy and stuff. Second law of thermodynamics, so I think it's entropy and stuff. Based on the results found in the previous part, which of the following processes are not reversible? Melting of ice in an insulated ice-water mixture. Okay, it's definitely reversible. Lowering a frictionless piston in a cylinder by placing a bag of sand on top of the piston. It should be reversible. Lifting the piston described in the previous statement by removing 1 grain of sand at a time. Freezing water originally at 5 degrees Celsius. Bro, shit is terrible. I don't know why I keep drinking it. They better put spicy salsa in this shit. They didn't give me any on the side. And there also better not be bacon in this. I asked specifically for no bacon. If there's bacon in it, I can't eat it. I'm gonna have to like give it to my sister or something. Okay, so far no bacon. Okay, I feel like I should thoroughly understand this question though. Okay, this one has a large temperature gradient, so we know that that one can't be true. Lowering a frictionless... Gosh, I can't see my computer screen. So this one's not reversible because pressure, there's a large pressure gradient. Thought I saw bacon, I was about to freak. Okay, here we go. Okay, wait, what even is the second law of thermodynamics? Somebody jog my memory. And by somebody, I mean my lecture notes. Ideal gas law First law. Okay, so this is all first law. And it was everything I did yesterday. So I imagine the second law should be here somewhere. Heat engines. So I assume we're doing heat engines as well. Real world heat engine example, yeah, whatever. Internal combustion engines, refrigerators, heat pumps, the Carnot cycle. Wait, so where do we get the second law of thermodynamics? Am I missing something? Oh, second law of thermodynamics. In entropy. Heat cannot by itself pass from a colder body to a warmer body. Okay. Yeah, that makes sense. Cannot have 100% efficiency, yeah, obviously. Okay, more entropy. Okay, so how does the second law of thermodynamics? But I think we're on thermodynamic devices first. A diesel engine performs an amount of mechanical work equal to 2,700 joules and discards an amount of heat equal to 4,000 joules each cycle. How much heat must be supplied to the engine in each cycle? Okay, great. So, this is a diesel engine. Let's go to heat engines. Okay. Or I guess this is an internal combustion engine. Gosh damn it. Okay, internal combustion. Oh, this is before the Carnot cycle. Wait, this is before heat pumps? Yeah, internal combustion engines. Oh, where's like the definitions and the formulas? Okay. Heat engines. Okay. So heat engines operate pretty similarly to heat pumps. So yeah, we obviously have the and we get an output of work. Okay, so we use delta U equals Q minus W, but this is zero. Well, I guess we can just write it. Delta U equals 0, so Q equals W. Yeah, if it's cyclic, then delta or W equals Q. I could say that. Oh, but we're asking about the heat supplied. This is the supplied. This is supply. This is waste. And that's work, obviously. So we know QH equals work plus QC. Okay, so it's asking about the supplied. So the supplied will equal 2,700 plus, is that 4,000? Yeah, so what is that? 6,700. Wait, let me drink this one. Bro, this one's good. The other one's shit. This one's good. What is the thermal efficiency of the heat of the engine? Okay. The efficiency. The thermal, well, I guess the lowercase t. The thermal efficiency, capital T is temperature, is QH minus QC over QH, right? Or work over QH. And we have work and we have QH, so work is 2,700 number divided by QH, which is 6,700. 0.4. Express your answer in percent. So what is it, 40? He's asking for 40%? Wait, express your answer in percent. Well, 40.3. That's not quite right. Please check your formatting. Like that. Yeah. I was gonna put point 403, but it's not what I asked me to do. An aircraft engine takes in about 8,900 joules of heat and discards an amount 6,400 each cycle. What is the mechanical work? Work equals QH minus QC. As we can see by the diagram. Work equals QH minus QC. So 8,900 minus 6,400, 2,500. What is the thermal efficiency of the? It's the same stuff, dude. We're doing the same stuff. Okay, so work is 2,500 divided by QH, which is 8,900. 28%. 28.01. Wait, no, 28.1. 28.1. 28.1. Gas engine has a power output of 20 kilowatt hours. It's a bunch of horsepower with the F. Thermal efficiency is 22%. How much heat must be supplied to the engine per second? Okay. I don't know. Hold on. I hear someone behind me. Hold on. I need to go to the fire. I'm really cold. Okay, I've heated up a bit. Well, I heated up my back. Okay. How much heat must be supplied to the engine per second? Joules per second. Why are we per second here? Work is a watt. A watt is a joule per second. So let's convert it from kilowatts to watts. It's just times 1,000, right? It's times 1,000, right? Am I tweaking or no? One kilowatt is 1,000 watts. Am I being, yeah, 1,000. Yeah, no. So we have 200,000 watts. So we have work, power output. Yeah, so work equals 200,000 watts. 1,000 joules per second. So if we want to get how much heat must be supplied to the engine? It's okay. So we know that T efficiency is equal to work over QH, right? So that means that QH is going to be equal to work over the efficiency. So we have Q equals 200,000 joules per second over, what's the percent? 0.22. 0.22. Divided by 0.22. 90, 90, 90. Wait, is that possible? Wait, it's not 200,000, it's 2 million? Shit, it's 2 million, not 200,000. It's crazy. Wait, but shouldn't it be 2 million? Or 200,000? It should be 5 zeros, not 6. Wait, it is 5 zeros. Oh, because it's divided. Okay, wait, no, chill. It is 5 zeros. It is 200,000. So this equals 90, 90, 90.9 joules per second. That can't be right. 90, 90, 90. Okay, wait, hold on. I don't even know what I'm writing. 90, 90, 90.9. That's what my calculator says. 90, 90, 90.9. Alright. How much heat is discarded by the engine per second? Okay. So this can be found because we know W equals QH minus QC. And now we can just say, so QC is just going to be the difference between work minus QH. Oh no, QH minus work. But it's the same thing. It would just be the absolute value of the difference regardless. So work equals 200,000 minus this. So we get QC equals 70, 90, 90.9. Okay. We're back to these 27-part questions. Okay. adiabatically. Oh my gosh, you piece of shit. To use variables, the pressure and volume of the gas in state C are PC and PVC, respectively. How much heat QAB is added to the gas as it proceeds from state A to B? How much heat is added to the gas? 0. Right? The gas is allowed to expand. Is it serious? Is this like a trick question? No, it's not. How much heat QCD? Bro, it's also 0. Oh, can they be serious and ask serious questions? Okay, C, what is delta U, the change in the gas's internal energy after a complete cycle? Express your answer in terms of any needed variables. So this is the first law of thermodynamics, Q minus W, but I don't think we should be using the first law. Oh, you know what? It's a cycle. From what? After a complete cycle? It's a cycle, so it'll be 0 as well. No, this is stupid. Can they be serious for once in their life? You know, positive work to be done by the gas. Okay. So clockwise or counterclockwise? Clockwise will expand. Wait, we want what? Positive work. Well, wait. Oh, it matters if A to B is positive. That's the only thing that matters. If A to B is positive. So we want it to go from A to B, left to right, because we need an increase in volume. From A to B, left to right. Yeah. Bro, I hate these embedded scrollers. Like, it's impossible to scroll up and down the window because you have to use both. It's really stupid. A freezer has a coefficient of performance of 2.4. The freezer is to convert 1.8 kilograms of water at 25 degrees Celsius to 1.8 kilograms of ice at negative 5 degrees Celsius in 1 hour. What amount of heat must be removed from the water at 25 degrees Celsius to convert it to ice at negative 5 degrees Celsius? Okay. So we know the specific heat and we know the latent specific heat of fusion. Does it just want us to use that? It's in joules. Okay. I guess we just go back to like what we used to be doing. So Q total is what it's asking for, right? Is gonna equal Q to get it from 25 to 0. and then Q of like freezing, so fusion, plus the Q of 0 to -5. Okay, so from 25 to 0, yeah, it's delta T, so it's gonna be the same. We have, we want to use our old equation. So first of all, we need to put up here like Q equals mc delta T. Right, okay. So mass of the water, it's all 1.8 kilograms. Okay. 1.8 kilograms. We might have to convert it depending on what our specific heat is in. No, okay, we don't have to convert it. Our specific heat is going to be 4187 joules per kilogram degrees Celsius. And then that's going to be times our change in temperature. 25 to 0 was going to be 25 degrees Celsius. Celsius cancels, kilograms cancel, and then we're left with joules. So we have 1.8 times 4187 times 25 equals 188415 joules. Okay, the Q of F is going to be equal to the mass times latent fusion, which equals 1.8 kilograms times, the fusion's going to be, first of all, it's in grams. It's 334 joules per gram. So we're gonna multiply that by 1,000 grams, and that should get us joules per kilogram. 334,000 joules per kilogram, and there's 1.8 kilograms. So this is 601,200 joules. And then Q of 0 to -5, 0 to 5, it's the same thing. It's going to be 1.8 kilograms times the latent, or the specific heat of ice, which is 2090 joules per kilogram degrees Celsius. Kilograms cancel, of course. And then our change in temperature is going to be 5 degrees Celsius. These cancels, we're just left with joules. 1.8 times 2090 times 5. We get 18810 joules. And now it makes sense that that's the lowest. Okay, so 18,810 plus 601,200 plus 188,415. So my QC 808 425. Why do I hear voices? That's why I hear voices. The mosquito fiending to get in to my Okay, perfect. How much electrical energy is consumed by the freezer during this hour? Okay, so let's draw our thing again. So, oh, this is a freezer though. Okay. So a freezer gets an input of work, also an input of cold, and an output of hot. Wait, let me think. Oh wait, no, it would be an input of hot and an output of cold, no? Wait, is it not an input of, am I tweaking? I think I'm tweaking. I think a refrigerator is, I think this is for a heat pump. Well, actually heat pumps and refrigerators should have the same. I think I know it's wrong then. Let me find refrigerators. No, where's refrigerators, dude? Internal combustion engines. Oh, heat pump here. A couple pages back. Oh wait, no. Oh wait, no, that's a. Yeah, refrigerator is the same. Yeah. Well, they can't even flow the other way because it can't flow from hot to cold. You know, but there is an input of work, so. But no, so this is right. So as we see, we get QC equals actually we get QH equals QC plus W. So work is going to be equal to QH minus QC. Okay. QH, because we have QC. Is there another way to find work? Let's look at my equation sheet. Okay, so we can also do it with thermal COP equals QC over work. And we have QC and we have COP, right? COP is what, 2.4, right? And we have our work, or not our work, our C is 808,425 joules over our work, which we don't know. So we just do that divided by 2.4. And we get work equals 336843.75. How much wasted heat is rejected to the room in which the freezer sits? Okay, so that's the QH. So we have our work. Our work equals 336843.75 joules. And that's going to be equal to our QH minus QC, which is what? 808,425 joules. So this plus this, we get this huge number, 1145268.75. Okay, this homework assignment is so much easier than yesterday's. Well, I say that now. And I'm only on question 7, so not really that far ahead. But this is a pretty good pace. If I can just keep cranking the questions out like this. Well, actually, this is pretty slow. Comparable to like last night. A refrigerator has a coefficient of performance of 2.2. Oh, that's what COP stands for, coefficient of performance. Each cycle absorbs that much joules of heat from the cold reservoir. So what are we saying? We're saying QH a refrigerator. Okay, so let's draw a refrigerator again so that we can ingrain it in our brain. No. This is QH. Okay. So let's set up our equations. We have QC equals, not QC, QH equals QC plus work, or work equals QH minus QC. Okay. And our COP, so I think he's saying that this prompt is saying that this is our QC, because TC would be our cold reservoir, right? Guess you could count this as a cold reservoir too, because it's not hot until you input the work. But I don't think that's what it's talking about, and we have no way of calculating this reservoir here. Or, I guess in this absorption would be QC anyways. Okay, so yeah, QC equals that, and oh wait, actually, okay, whatever. Okay, so we have the COP, we have the QC. So for a refrigerator, this is a little bit different because we have our COP is going to be equal to, was the last question not a refrigerator too though? And this is going to be equal to QC over work, I think. Bro, wait, but the last question was a refrigerator too, and I used the other, oh no, this is a freezer, it's the same thing. A freezer, but I used the other equation, work equals Q, oh no, I used QC over W again. Okay, no, it's fine. So this time we're trying to calculate the work. Oh, it's the same thing. Work is going to be equal to 3.78 times 10 to the 4th joules over what, 2.2? Yeah. 3.78 times 10 to the 4th divided by 2.2. It's 17,181.81, and this is going to be joules. Can you get off my desk, dude? No, you can't lay down on my mouse pad. No, you can't, dude. I'm sorry. You can lay down over here. Yeah, there you go. You can't lay down on my mouse pad. You just get too much. No, you can't. You definitely can't lay down on my keyboard either. No, not there either. Well, my mouse pad, because you get hair all over my mouse pad. Nope, not on my iPad. Oh. Nope, not on my lap. Let's go down. There you go. Now you got a good spot. Down there is fun. Okay, so we have our work and our QC. So now to solve for our QH, we just add the two together. So we get this plus this, and we get this. 54,981.81 joules. Nice. Who's here? Why do I hear like professional footsteps? Alright, buddy. Alright, now we're looking like we're getting a little bit more complicated stuff here. I do need to use the bathroom now. Been drinking these damn protein shakes. Alright. Let me drink my... What the fuck? I'm gonna draw what a real heat pump looks like. Because they use stupid drawings. is what a real heat pump looks like. With our TH. QH equals QC. Can I use QH and QC? Okay. Well, there's a couple equations you can use. Work also equals, this is for a heat pump. It's the same as a fridge. So work will equal QC over the COP. Alright, and they call it K. K sub what? Fridge. K sub fridge. Well, pump. I don't know what this is. Netherlands. K pump. What are you doing there? Or QH. Bro, can you please be quiet? Okay, so that's my next answer is work equals QH over K-pump. But it says that it's not related. Does not depend. Check your signs. Bro, stop. I should have read the question, because it does say what is the relationship of the work in to the work done. The work done by the system Dude. Okay, find QH, the heat pumped out by the ideal heat pump. Bro. Do you not understand? How many times do I have to move you away from that? It's a Carnot cycle. Is it 100? Oh, in terms of TH and T, okay, so we have our Carnot COP. Inside the TH. So we have an input of TC, so our input is gonna go in the numerator. Okay. So it actually doesn't go in the numerator. It's this one. Wait, why is it that one? Because our goal, does our goal go in the numerator? Yeah, our goal. Our output goes in the numerator. Apparently. The heat pump is designed to move heat. This is only possible if certain relationships between the heat and temperatures at the hot and cool. I think this is like just common sense, no? Okay. Our cost is gonna be cost ideal divided by k. Our k is going to be equal to 0.75 times the k Carnot. So that's going to equal to 0.75 times we need the temperature in Kelvin, so 47 plus 273.15 is 320.15 over 320.15 minus 2. That equals times 0.75, 5.3. So we do 1,000 divided by 5.3. We get $187.64. Oh no, $187.41. Okay, now we're about halfway done. Okay, multiple choice, nice. An ideal gas is combined within, let me get this back, and I want a piece of gum as well. Discord. Bro, leave my mouse pad alone. It's tired of your cat hair. He's just clicking my mouse buttons. Like, what are you doing? Um, um, well, actually, they're individually. Yeah. Mainly because of the engineering. And no, actually, that's not true. Literally every aspect of all four of these things. Yeah, they're direct subsets of STEM, right? Because they're part of computer science, which is science, obviously. Definitely part of technology. Arguably engineering. My school would argue that it is engineering because that's where they teach it, is in the School of Engineering. And definitely mathematics is a huge component of. Is there a major that includes only math, computer science, programming / coding? At my university, yeah. Typing it out for, because I mean, otherwise it just looks like there's unanswered questions in the Discord. At my school, I don't know if there's a degree that includes only math and computer science. I mean, there's like a degree literally called math plus CS. And if we look at like the degree requirements, what the fuck is going on? This one? What's going on? Can we get like bro, these links are dead. These links don't work. Degree requirements. Bro, these links don't work. Oh. There it is. I'm an idiot. Okay. CS. Bro, come on. Get out of my stuff, dude. Stop. CS, math, CS. Well, it looks like this is all CS and math. So yeah, there is a major at my school. It's called Mathematics and Computer Science. It's in the School of Liberal Arts and Sciences. It's not in the School of Engineering. If you care about those sort of things. Why do you need chemistry for CS? Computer science. But that only really matters if you're going into like engineering. But only C, computer programming. Boot camp. Yeah, I would be a software engineer. And that's why I'm not a software engineer. Boot camp is not a major. Boot camp is like an online. It's like. Yeah, I don't know if there's any majors. Boot camp is not a major. Let me just. Easy. Thumbs down. Well, actually, not thumbs down, because it's not a thumbs down. It's just like a no. No. This one. So remove the thumbs down. Software engineers don't live the best lives. Boot camp. Oh, and oh. Yeah, there you go. Software engineer, boot camp is like an online school that teaches you CS. Well, not really CS, but just like programming. Mainly just like programming. Please help you with that. Use like Mathway or Photomath or something. The first one I would do integration by parts maybe. And then the second one is that's like X arctan X or something. Arctan or maybe, yeah, I think it's arctangent. The first one is integration by parts, and the second one is arctangent. I think you can do arctangent. Or actually, you could also represent the series as a summation. You could represent the series as a summation if you know how to do that. I'm trying to think if you can do that. I think you can do that, no? Yeah, you should be able to do that. Yeah, you can solve that problem with Photomath and ChatGPT. Those are two pretty simple integrals, so ChatGPT and Photomath shouldn't have any problems with it. Why is that? They generally get paid less or what? But maybe integration by parts doesn't work for the first one because t to the negative one doesn't really simplify after you take the derivative. Oh, but you can choose to take the antiderivative of it. Oh, but the antiderivative will just give you a natural log, so you wouldn't want to do that. No, I don't know. Yeah, maybe integration by parts would not work for that one actually. Interesting. Oh, wait, what am I talking about? Integration by parts. It's just a U substitution, no? No, it's not. It's not. It's not. No, it's not. It's not a U sub. I don't know. Let's try something. It's fun. Yeah, here you go, literally. Before I could even say a word. Okay, yeah, integration by parts, exactly. And then the second integral. Oh, you can do integration by, or you can do U sub for this one. Oh, interesting. I was gonna use arctan, but that looks a little bit simpler. Yeah, you have to. Oh, even if you don't pay, you can paste chat images to ChatGPT. You don't really like to resort to using ChatGPT? Yeah. I mean, I used to have predispositions to using chat, but it's just become so beneficial to me as a student and as a learner that kind of curbed that. And now I just use it because it's genuinely helpful. Bro, calculate the short-term speed of a point on Earth. No. That looks pretty simple though. It looks like there's just like an equation that you can plug that into. It's generally how those short physics problems work. Identifying the equation is difficult, and I can't do that off the top of my head. Maybe given an equation sheet I could, but no. Yeah, I want to know what he means by devs don't get paid well for the amount of work they do. Well, nowadays, because a lot of the devs that get paid well and do little amount of work have gotten fired. That's why the job market is so terrible. Because now you actually have to put in work to make money. No, but web developers for sure don't make a lot of money. Because web development is like, it's really dying. Because anyone can be a web developer with ChatGPT. Yeah, but if you're not talking about web development, software engineering, software engineering is starting to become a more real career in the sense of like you actually have to do work now. It used to be like you can just like not do any work and get paid a lot of money, but everyone that did that got fired, and that's why everyone's complaining about the job market and stuff. The job market's still actually fine. It's just you're now gonna genuinely have to be a competent worker and put in a lot of work to get paid a lot of money. So as long as you're one of those types of people, job market's not bad. AI programmer, do they get paid good? Depends on what you define as getting paid good. It's well, first of all. You should use the word well. Good is an adjective, and you need an adverb to describe paid. Paid is the verb. And so you need an adverb, not an adjective. Also, the world is getting saturated with CS majors. I don't think I would agree with that. Sure, there are a lot of CS majors, but CS is still one of the hardest degrees to get from school. So an increase in CS majors would not mean that the market is becoming saturated, because there's an infinite amount of computer science problems to be solved. Literally, that was like someone's thesis. A very famous computer scientist, his thesis was about how computer science creates more and more problems. So I wouldn't say it's getting saturated. I would say it's exploding and becoming a lot larger. And I think people do confuse that with saturation, but I would not agree with that. I don't think it's being saturated. What do you think about health engineering? I haven't heard of it. I've heard of bioengineering and stuff, and I think that stuff is great. Anytime where we can have engineering with a cross between another discipline of science that genuinely helps people, like health, medicine, stuff like that, I love it. I love to see it. I mean, that's ideal, right? Health engineering probably is the most rewarding job you can get. You're helping people's lives in like a very meaningful and impactful way. Want to get into this neuroscience and AI stuff? Yeah, I do too as well. What do you think about DevOps? I don't know what that is. Yeah, that's a common thing, AG. I think this is Ollie. Most of the programmers say that CS has taught them nothing about programming and solving real-world problems in programming field, and that's like why you would do a boot camp opposed to taking a CS degree, because CS is going to teach you science, computer science, and a lot of the time also teaches you engineering as well, and those things are not necessary to becoming a programmer. At a CS, when you take a CS degree, you're going to be taught engineering classes, physics, math, chemistry, computer architecture, a bunch of different classes that are going to have nothing to do with programming, because you're becoming a computer scientist and not a programmer. Programmers can take boot camps and you can learn all the information you need and solve leak code problems. That's probably how you're going to get to solve real world problems in the programming field, to become a software developer. But if you want to get into AI and neuroscience and machine learning and stuff, then you need a CS degree. You need to become a computer scientist, because you need to understand how the machines that you're programming work. And to do that, you need to understand physics and chemistry, and it's crazy the science that goes behind it. You'd be surprised. But yeah, this is definitely a true statement. I know people who graduated from like Stanford in computer science and they just complain about how bad their degree was, but it wasn't a bad degree. It was, on their part, a bad choice in degree, because they didn't understand what computer science meant. Dissatisfaction with the application of your major to what you do is not at, the school is not at fault for that. You are at fault. It's your ignorance of what you're getting into. So that's my little rant for that. Oh crap. Yeah, I don't know what DevOps is. Discrete math too. Yeah, discrete math is a huge part of computer science. Huge, it's crazy. It's like the first 2 years of school you'll be taking your discrete math classes and they kind of suck. Should I change my Windows to Ubuntu? It's a personal choice. Unless you have a real reason for changing, I really wouldn't change, because there's no point. Ubuntu has way less functionality, has way less proprietary softwares that work with it. You can't download like Outlook or a bunch of apps. Like literally no apps that really are supported on Ubuntu. So I don't recommend it unless you have a genuine reason. That's your conclusion? Yeah, I mean, that's a pretty decent conclusion. I mean, that's at least the way I'm taking it. There might be a more optimal path, but that's what I've noticed. I've noticed, like, if you look up any AI researcher, they all have degrees in STEM, particularly in CS usually. Some of them with physics degrees, but mainly CS. Or some with biology degrees, actually, for neuroscience. But for AI, I think CS is a great choice for a major. But CS just for programming depends on your school. For my school, I don't think it would be worth it. Going to 4 years of learning all these hellish classes about abstract concepts and crazy deep level physics and engineering and discrete math, I don't think it would be worth it to take those classes if all I want to do is program. Are you running Ubuntu? I am running Ubuntu. Is it like a Mac style on Linux? It's pretty different than Mac, but it is pretty similar, I guess. I don't know, it's more similar to Mac than Windows, but it's still not that similar. Yeah, that's great. Yeah, I think health engineering is great. Those seem like two great paths to go into. I love it. I love seeing STEM be directly applied to like solving genuine problems for humanity. And health and Biology is a great way to do that. Yeah. If you don't want to take physics, then do not come and do pure CS at my school. You can do a CS plus, like CS plus math, but then again, it's not in the School of Engineering, and that's really where most of the computer science research gets done, is in the School of Engineering. Well, actually, all of the computer science research. Be the best in your class, that's great. You don't have to go to CS to become an AI engineer. You can look up like people who you like. They go into all these different majors. I mean, there's people who are like history majors and they end up becoming AI engineers. I mean, you just have to learn the information at some point. Whether you learn that through your bachelor's degree or not, it's kind of up to you, but yeah, CS is definitely, well, because you're trying to make a computer mimic a brain, right? And to do that, you have to understand, first you have to understand all of the aspects of the brain, and then you have to understand all of the aspects of the computer that you're trying to program. So you have to understand how the tensors in the GPU work together and how you can make them mimic neurons and how you can, so, I mean, it's so crazy. You wouldn't even believe it, but so you definitely need computer science to some degree. Whether you get a bachelor's degree or not is up to you to learn to be an AI engineer. Brain neuroscience is mainly biochemistry. There's a little bit of physics actually with how your neurons communicate with each other, because they use electromagnetic pulses. So there's actually a lot of physics there. There's a whole degree called biophysics. And inside of biophysics, there's a discipline for biophysics in neuroscience. And so neuroscience definitely has a lot of physics in it, but will you be learning that physics in school is kind of up to you, because you get to choose like what classes you take. So you can be chemistry based, because chemistry and physics are very similar. Like when you watch me do my physics homework, like it's basically all chemistry. So physics and chemistry kind of go hand in hand. They play with each other, and that's why a lot of the a lot of the prizes like Nobel Prize and a couple other like awards are given in both physics and chemistry, like under the same discipline. And Newton was a physicist and technically a chemist, and so was a bunch of Oppenheimer, chemistry, physics. It's all works so well together. Why don't we hook up a bunch of brains and make a computer? That's like Psycho-Pass. This anime called Psycho-Pass. That's literally what they do. They make a ginormous computer out of brains. You can learn to program via YouTube, even if you are not in the CS major. Yeah, exactly. You can learn it anywhere. YouTube, anywhere. Yeah, ideal gas law is everywhere in chemistry and physics. I've been doing PV equals nRT all day. But I gotta get back to work. So I'm gonna get back to work soon. Isn't a thing that some people are doing, like neural networks is, I think, what you're referring to. Yeah, neural networks. So there's a bunch of different types of neural network: convolutional neural networks, recurrent neural networks. There's crazy ones. There's LSTMs. Yeah, no, it's crazy. Get back to work. Yeah, I will in a split second. But yeah, neural networks is essentially what you're doing is you're trying to make the computer mimic a brain, and you can be a you can develop neural networks without really understanding what's going on. But if you want to be like an AI engineer, which is someone who like optimizes and creates these programs, you're literally gonna have to like completely understand how the machine is interacting with the code and how the code is forcing the machine to do these different things. And like to some extent, like some AI engineers even understand like each line of code, like how the electricity is like being flown through the machine. So it's kind of crazy. So you definitely need like a lot of computer science for that. Yeah, there's a course from Harvard called CS50. I did it. I personally didn't like it, but again, I'm not a programmer, so that's probably why I didn't like it. Just tuned in the stream in half an hour ago. I'm gonna start studying for my exam tomorrow as well. Good luck, brother. Good luck on your exams, everyone. Good luck on your exams too, bro. Yeah, I've got one this Sunday. LOL, I should be speedrunning physics right now. Yeah, that's crazy. I don't even know what the hell that is. Yeah, CS50 is free. Good luck on your exams, geometry, algebra, and physics. Yeah, you most likely will have a comfortable salary at the end. And I mean, to get through a CS degree, well, depending on the school, from my school, like you definitely develop a lot of good habits, a lot of hard work, and a lot of ambition because it's very difficult and very competitive. So like those skills are applicable to any discipline, like whatever you go into, whether it's programming or not. Those undeniable skills are great to have. Are we really taking the same physics class? Are you in university or high school? You must be taking AP Physics, Electricity, and Magnetism, except they don't really go into thermodynamics. So that's interesting that you're in the same physics as me. That's pretty cool. High school in Greece, yeah, exactly. It's a different country, so that's probably why. I'm heading to bed. See you later, bro. Yeah, me too. See you. What's the difference between information technology and CS? I don't really know. That's actually a good question. I don't know. Got distracted a lot by. All right, see you, bro. See you. All right, let's get back to work. Do we have water? Do we have music? Yeah, we do. Oh, I gotta stop. Okay, I can't press my AirPod button. It overrides the AirPlay connection. Let me get. I wake up at night. Okay. An ideal gas is combined within. So the N atoms. So there's a volume change. Oh, the temperature remains constant. So the pressure remains constant. Because the volume is expanding. Remains the same. Use the ideal gas law. The temperature of the gas and the number of particles remain constant. Does the volume of the gas increase or decrease? How then must the pressure change? The volume increases. Oh, so the pressure decreases. What am I talking about? Yeah, I'm an idiot. That's so stupid of me. I don't know why I said remains constant. I knew that. Is the internal energy of the gas the same before and after Q is added? Why does it always do that? Okay, wait, let me just write out our laws here. Okay. These are our laws here. All right. Forbid converting all of the absorbed heat into work done by the piston. Let's review the second law of thermodynamics and see if that's well, this says in a cycle. Yeah, so since this is not a cycle, it's a no. If it was a cycle, it would be yes. And the Kevin Planck statement, yeah. No. You piece of shit. Oh, dude, I always do this. Delta U is not constant. U is constant. So delta U equals 0. And so 0 equals Q minus W. So Q equals W. I always do that. I'm so stupid. I gotta stop doing that, like, seriously. Does the magnitude of the force that the gas exerts on the piston depend on the piston's area? Yes. Is the total work done by the gas independent of the area of the piston? Yes. The work is just dependent on the heat. Bro, I'm pretty sure. Okay, wait, let me see what I got for getting that true-false question wrong. 78%? Wait, I got 0% on this? Oh my fucking gosh. I'm leaving. I'm getting off. I'm getting off. I'm dropping the class. What a joke. Okay, Carnot engine. Bro, stop fucking all my stuff up. So a perfect engine. Okay, what is this? An engine. So an engine outputs work. I think it goes this way. Wait, no. Oh no, yeah, this is right. Yeah. So this is a heat engine. How much mechanical work does the engine perform during each cycle? So we get QH equals work plus QC. Okay. Takes in 550 joules of work, or of energy, and gives up 335. So only 215 joules are converted into work. What is the temperature of the low temperature reservoir? Interesting. So we can get the COP is going to be equal to QH over W, which is also going to be equal to TH over TH minus TC. Or in other words, wait, this is an engine. This is an engine. It might be TC over TH minus TC. Oh, here. Since it is a Carnot, we can use QC over QH equals TC over TH. Oh, that's even easier. Where do we get that equation from, though? I don't know if I'd be able to derive that myself. QC over QH equals TC over TH. Yeah, and the COP. Oh no, that's the efficiency. Yeah. Okay, so we can calculate the temperature. So we have QH is gonna equal 550. 550 over 335 joules equals TC over 620 Kelvin. What? Oh, QC over QH. 550, 335. I was gonna say, the fraction has to be less than 1, so I was really confused. So 335 divided by 550, and then multiply that by 620. Our TC is 377.63 Kelvin. What is the thermal efficiency of the cycle? This is easy. Thermal efficiency is going to be equal to QH minus QC over QH, which also equals 1 minus QC over QH. Okay, so 1 minus QC over QH. Wait, but why do we get a 1 minus? It's just going to make it negative then? QC is 335. QH is 550. Oh, wait, no. Or, yeah, the fraction is less than 1. Okay, so we get 0.39. Oh, so 39%. And that should be the same as if I did 550 minus 335 over 335. Oh, no, over 550. Yeah, it's 39%. And then if I do the Carnot, it should honestly be the same. So TH is 620 minus this 377, and then divided by 377. Wait, but now we get 64%? Oh, divided by TH, sorry. Divided by TH, 620. Yeah, 39%. So no matter what, it's 39%. 39.09%. Okay. An ice making machine operates in a Carnot cycle. It takes heat from water at 0 degrees Celsius and rejects heat to a room of temperature 26 degrees Celsius. Suppose that a mass 85.5 kilograms of water at 0 degrees Celsius is converted to ice. The fuck? I didn't even listen to a single word that I just read. I was just reading and not paying attention. It's because this song's ass. It's dead ass why? The song, the title sounds like oh, it's Girls seem to like the boys. Oh, boys seem to like the girls. Damn. How much heat is rejected to the room? Okay. Let's draw this. So what do we have? A fridge, an ice making machine. So we input work. Good. You'll be right. Wait, I think QH actually is gonna equal what do we, yeah. is in a Carnot cycle. QH over QC or QC over QH? QC over QH equals TC over TH. Okay. QH does not equal MLF, does it? No, QC equals MLF, right? Yeah, I think this is the right answer. Okay. Mass is 85.5 kilograms. What the fucking shit? Dude, come on, that cannot be the answer. So we're getting QH is gonna equal okay, wait. Let's look at these processes. I don't know. I think I have to redo this. Let's try it. 312,75220.76. That's crazy. How much energy must be supplied? Yeah, and then this part's easy, AF. Work equals QH minus QC. And we can just do this minus 28. 2718220. Okay, now I need to turn the fire off because now I'm hot. How much heat does the engine extract? Oh, I'm hot. Like, genuinely, I'm hot. Oh, this kid never answered me if he wants to play tennis at 7 p.m. I'm either gonna go play tennis at 7 p.m. or I'm gonna go to the ice arena at 6 p.m. A Carnot engine has an efficiency. Okay. So Carnot efficiency equals TH minus TC. The same. I think this also equals Q work over QH. 0.66 equals exhaust at room temperature, so that's 293.15. I get 99.61. Oh, wait, we're trying to find TH. Oh, I'm an idiot. We know TC. We're trying to find TH. Well, we also know that it's Carnot, so QC over QH is going to be equal to TC over TH. QC is going to be, what is this? This is an engine. So in an engine, we have TH, TC, and then we have work as an output. Wait a minute. I think the arrows point the other direction. Yeah, they do. Because if you think about it, like the engine is going to be colder than the outside world. Or the engine is going to be hotter than the outside world. So okay, QH is this 3.2 times 10 to the fourth number, and work equals, so this plus, oh no, QC equals this minus the work, 2.1 times 10 to the fourth. Yeah. So if we do TC, 293.15 divided by that. Oh, I subtracted it. Oh yeah, I subtracted it. Yeah, so this divided by, what was our QH? 3.2, 3.18. So 0.34. TC, 293.15 divided by this number. 862. Oh, degrees Celsius. Minus 273.15. 589. Sophomore with nothing better to do. Okay, you're on his ass. Right? Oh, constant temperature. Oh, this only works for constant temperature. But it is constant temperature because we're at 0 degrees Celsius. Delta Q is going to be equal to MLF kilograms. We're going to have 0.47 kg times LF is 334 joules per gram, right? We memorize that? Yeah, buddy. So times 1,000 kilograms, or grams, 1,000 grams. Zero 0.47 times 334 times 1,000. Delta Q equals 15,690. Wait. Oh, Kelvin. I was gonna say, like, how can you possibly do this if it's at 0, but it's at 273.15? T equals 273.15. Because there's no 0. You can't deal with zeros, not when it comes to stuff like this. Hello? I won't be done studying until like 8 p.m. No, I'm at home. You can just take my car. But you have to be back by like 5 or 6 or 6. You have to be back by like 6, 5:45. Yeah. You have fried rye. Okay, it's fine. Either way. The fried rice? Yeah, I had it last night for dinner. Bro, Mob is actually like heating up. Like it's actually getting good. His brother just got powers. It's kind of raw. Well, obviously, I already saw like his brother. Who's Reagan? That's his mentor? He's low-key been absent for the past like 3 episodes. He's kind of a loser. Him? Yeah. Yeah, no, he is funny. No, Mob is him. Well, he's gonna do it because he needs to save his brother because he's like really mad actually now. But don't spoil it. Stop. Let's just stop talking about it. See ya. Bye. This nigga's always trying to spoil some shit, bro. Every conversation. And the source of heat is a very massive body at temperature 20 degrees Celsius. What is the change in entropy of this body? So it's going to be the same divided by 273.15. 273.15 plus 20. 293.15. 535.49. Oh. Wait, what? Okay, wait. I think I know why. I think because for our new delta S, we have delta S equals delta Q over T. Our T is correct. It's 293.15. But our delta Q is going to be equal to Q 20 to 0 plus Q L. QF, because it's just Q of fusion. So Q from 20 to 0 is equal to, is a very massive body. Oh, but it's just a very massive body. So we don't even know. We don't know what mass. Oh, it just says check your signs. I should have read that. Why is it negative? Why is it negative? Wait, so no, I was right. Let me stop doing this. So it's the same Q. Why is it negative though? Because the heat is leaving? Oh, I guess because delta Q is negative. Because it starts from what, 0? Yeah, negative. I mean, I always think of heat as a scalar, but it's a vector. Wait, heat's a vector. That's definitely a question I got wrong on my exam. They asked that question last week. I just realized that. What is the total change in entropy of the water and the heat source? Was it just them added together? $575 minus this. 39.2. Oh, yo, what's up, Rob? I didn't see it. I'm not looking at chat because I'm kind of trying to lock in. But what's up, Rob? I think I already made you a mod on Discord. Oh my gosh. 400 pounds of clothes are about to be delivered to my house for never alone. Heat transfer is a vector. Heat transfer and heat are this in this context are the same thing. It's Q. Q stands for heat transfer or heat. The rate of heat transfer is different. The rate of heat transfer, well, I guess it is kind of different. Heat transfer and the quantity of heat. But I don't know if there is a quantity of heat. I don't know if there's a quantity. I don't know what the equation is to measure the quantity of heat. So I guess heat transfer and heat are different. Yeah. Yeah, no, they are different. I was mistaken. Maybe. They might both be vectors then. Who knows? Who cares? You make tea with 0.25 kilograms of change in temperature is what 69 degrees. So 0.25 kilograms. We have 4175, 4187. Yeah, 4187 joules per kilogram degrees Celsius. And then we have 69 degrees Celsius. And we're just left with joules, which is exactly what we want. Okay, and now we need the temperature while it cools. The change in entropy while it cools. Okay, let's think about this. So this is just going to be equal to, time is not constant. So we think about dq. So this is what q equals, and if we differentiate both sides, dq, and it's respect to both because it's mc dt, right? So then we have the integral of mc d, as we do mc over t dt. Mc are constant, so we just get mc times the integral of 1 over t dt. And what is this from t? This is b. tc to th. So we just get delta s equals mc times the natural log of th over tc. Yeah, because we're cooling down. We should just do f and I, tf over ti, because it's cooling down. And we get the division from the log rules, obviously. Okay, mass is 0.25 times 4187. Let's put units, let's get units. Kilograms. And this natural log is going to end up being degrees Celsius. TF, let it cool down to TF of 20 degrees Celsius over 89 degrees Celsius. And that's going to be the same as if we did I think it's 20 divided by 8.9. 0.25 times 4187 times the natural log of 20 over 89. I don't think we have to convert it to Kelvin. We get negative 1562.69 joules. Oh, joules per second. Or joules per... Oh, Kelvin. Wait, why is this in Kelvin? Wait, this is not Kelvin. Wait, I think we have to change it to Kelvin. Wait, I think it has to be in Kelvin. What are our temperatures? 89 plus 273.15 and 20 plus 273.15. the natural log of, which one's in the numerator? 20 over 362.15. Times 0.25 times 4187. Wait, is it negative 221? I get negative 221. Actually. Because I changed it to Kelvin. Okay, yeah, that's right. Okay, the cooling process is essentially isothermal for air in your kitchen, or for the air in your kitchen. Calculate the change in entropy of the air while the tea cools, assuming that all the heat lost by the water goes into the air. Okay, that's easy. So this one we can actually use delta Q. Oh, degrees Kelvin, 293.15. You could be with me instead. What am I doing? It's not the right number. I don't even know what 270. Oh, 273 from like Kelvin, from converting Celsius to Kelvin. What is the total entropy change of the system T plus air? $25.12. Wasting time while you're wasting time when you should be with me instead. Okay, what do we know for a fact in a Carnot engine? We know that QC over QH is equal to TC over TH. So that implies that, well, it depends on what it's asking us. What is the Kelvin temperature of the hot reservoir? Exactly. Okay, so the engine's efficiency. Okay, so we know the efficiency is going to be equal to TH minus TC over TH, which is just equal to 1 minus TC over TH, right? And so that's going to be equal to 1 minus QC over QH. Is 72 degrees Celsius warmer than the cold reservoir? Wait, let me see if we have 72 divided by 1. No, that doesn't work. Because if we have like 82 divided by 10, it's not going to be the same thing. Yeah, so division doesn't work like that. Okay. In a Carnot engine, the hot reservoir is 72 degrees Celsius warmer than the cold reservoir. Okay, we can also use the equation. Oh, okay, wait. No. We can use this one, and with the efficiency. So our efficiency is 0.225, right? And we have TH minus TC is going to be equal to 72 plus, oh no, it's just going to be equal to 72 Kelvin as well. 72 degrees Kelvin over blank. This is going to be over our TH. So we do 72 divided by 0.225. We get 320 degrees Kelvin. But that might be degrees Celsius. No, it's Kelvin. Okay. What is the Kelvin temperature of the cold reservoir? It's just that minus 72. Yeah, 248. 248. An ideal Carnot engine operates between 600 and 200 degrees Celsius with a heat input of 250 joules per cycle. Okay, so QH equals 250 joules. Wait, can we see how this engine works? This is an engine, yeah. Outputs work. It goes this way, right? No, it goes this way. Yeah, that makes sense. So heat input is 250 joules. What are we trying to find? QC? Operates between 200 and 600 degrees Celsius. Okay, so we know QC over QH equals TC over TH. So we get 250 joules equals what? What is this? TC? TC is 200 plus 273.15, which is 473.15 Kelvin. And what's the other one? 600. Okay, so this is 873.15 degrees Kelvin. Then we divide these two. And then we multiply that by 250. We get 134.472 joules. 135. What minimum number of cycles is necessary for the engine to lift a 400 kilogram rock through a height of 100 meters? Okay, so let's think about these units. So what is that? That's 4 kilograms per meter, or 0.25 meters per kilogram. Okay, so that's what we need. Kilograms per meter, or meters per kilogram. Number of cycles. Okay, we did something like this. Hold on. In lecture. Asked us cycles. This is shit upside down. This is entropy. What's that noise? heat pumps. Okay, how much work the engine produces for each cycle? Yeah, we can use that because work is equal to joules. And joules is equal to Newton meters. Joules equals Newton meters. Wait, does joule... Oh, SI base unit is kilograms meter squared per second squared. Do we have a time? No. Okay, wait. Yeah, I mean, we did cycles, but... What the hell's going on around here? Okay. Okay. 400 times 9.81 times 100. 392,400 joules. Okay. So number of cycles equals 1 minus TH over TC. TC over TH. Or not N. So efficiency equals TH minus TC over TH. Okay, TH minus TC. 873.15. Let's get its fraction. Okay, 873.15 minus 473.15 over 873.15. It's 0.458. Okay. Okay, so to get the work output per cycle, we get, if we refer to this, the output is going to be QC. Wait, no. Wait, we want the work output, this output. The work per cycle is work equals QH minus QC. Okay, QH is 250 minus 135.472. So work per cycle is 52.46 work per cycle. So to get the number of cycles, we have to divide this by a work. Oh wait, no. Well, yeah. We have to divide this by the work. Well, we'd actually divide, because we need C to be in the numerator, so we want this to be in the denominator. So we want 392,000. Well, this is joules per cycle, technically. 392,400 joules divided by 52.46 joules per cycle. And these cancel and the C comes up top. So 392,400 divided by, we get 747.9.04 cycles. Oh. Wait, we did this incorrectly. The work per cycle, what did I even do? The work per cycle is 0.4, the efficiency is 0.48 times 250, the input, equals 114.527. That's the work. That's the work. Oh, so we could have just done work equals QH minus QC. We didn't have to do all this efficiency bullshit. Because it's the same number. Divided by 114.527. So again, 39,200 again, or whatever the number is. 3426. 3426.24. Last question. A certain heat engine operating on a Carnot cycle absorbs 370 joules of heat per cycle as its hot reservoir. Okay. Thermal efficiency equals work over QH. What's the percent? 26, 0.26. Okay. TH $145. So TH equals 418.15. Okay, it's a heat engine. So as we remember from a heat engine, okay, it wants us to solve for how much work does this engine do per cycle. Easy. W over QH. Our QH is 370 joules equals 0.26. So 370 times 0.26 equals 96.2 joules. What does it want us to find next? How much heat does the engine waste each cycle? So we have work equals QH minus QC equals 370 joules minus QC. So we get 96.2 equals 370 joules minus QC. So we get QC equals 370 minus that, 273.8. Okay, what is the temperature of the cold reservoir? Okay. Okay, wait. I think we can do at 22% efficiency or 26% efficiency. So I think it's like 0.26 of the Carnot efficiency equals the T efficiency. Wait. Yeah. Wait, no. Wait, yeah? Yeah, I think this is actually right. Wait, no. No. What is the temperature of the cold reservoir? I think this is actually I think that was actually right. I think QH minus QC over QH equals 0.26 times TH minus TC over TH. I think that was actually right. Okay. We know that this equals 0.26, but we know what TH is, so let's just fill in numbers here. QH equals 370, so we have 370 minus 273.8 over 370 equals 0.26 times TH, somebody in Kelvin please, 418.15 minus TC over 418.115. Bro, I don't think this is right. Hold on, let me see what the answer. Let me see what answer we get. 370 minus 273.8 over 370. Well, not 273.8. It's gonna be this exact number. Oh yeah, it is actually exactly 273. Yeah, and then we divide 0.26. We could just get 1. 1 times 418.15 minus 418.15 is 0. Yeah, that's stupid. It doesn't make any sense. That's stupid. So this is definitely not the right equation to be using. Um, ugh. How many D and okay, but we can go on to D. Oh no, we can't. The entropy of the world. Are you fucking high? Oh, this is a Carnot cycle. Duh, dummy. So this is the Carnot efficiency. Okay, the Carnot efficiency equals 0.26 equals TH minus TC over TH. So we just do 0.26 times 418.15 minus, oh no, and then we do 418.15 minus that. We get 309. Oh, degrees Celsius minus 273.15. 36.28. 36.281. Let's move on. Okay, by how much does the engine change the entropy of the world? So we're gonna have our delta Q. Our delta Q is gonna be our output, our QC. So we have 273.8 joules divided by 309.431 degrees Kelvin. 273.8 divided by 309. 0.88 joules per Kelvin. Okay, and then we also have to, it also inputs entropy. So we need to calculate, so we lose 370 joules from the Earth divided by the temperature of the hot reservoir, which is 418.15. And this is negative 0.88. So it's zero. It's 0 joules per Kelvin. What mass of water could this engine pump per cycle from a well 45 meters deep? Okay, so we're trying to find work equals force times distance equals m 9.81 m times 45 meters. 9.81 times 45. We have 441.45 m equals work. The work of this engine, the output work is 96.2 joules per cycle. Is that an exact number? 96.2? Yeah, 96.2 is the exact number. 96.2 equals 441.45 m. So the mass equals 96.2 divided by 0.2 kilograms of water. 0.217 kilograms of water. Alright. Another 98.5. That's so dust. It's because of this frickin' question. It's because I got the one true or false question wrong. I'm such an idiot. It's bullshit. Alright, so we're done with homework now. Should we do the lab? We gotta do the take-home lab, entropy take-home lab. I have to do this. Okay. Let me plug in my iPad. My hands are so sweaty. It's at 4 p.m. tomorrow. Sorry, I had to do this take-home lab. Let me pull it up on my iPad. What's this website called? Talon? There it is. Oh, there it is. Okay. My hands are so sweat. Let me open the window. Okay. Let's do this lab. I'm actually open maybe lecture notes or something. Yeah.
Alright, I take your car.
Okay. The method of mixtures. Quiet. What? 250 degrees Celsius? I don't like these C's. I like joules. I don't like calories. So we just multiply everything by 4.187. 80 times 4.187. Wait. Okay, wait. We have them on the sheet here. 4.187, 0.387. Ice is 2.09. And LF is 334 joules per gram. Okay. Okay. Okay, wait. Okay, wait. We have to. We also have to heat this ice up. Right? Wait, do we want to put the water on the other side? Are you guys serious? Did you not see that bird? Came right up to the window. Um. What? You gotta stop hissing at each other. Bro, you're stepping on my keyboard, literally. Bro. Fucking feet off my keyboard. Yeah, get off my desk, please. Thank you. Hold on, I'm taking a short. Oh my gosh. Okay, wait. I was gonna do something. Oh yeah, let me. Bro, the cat. The cat just broke through the window. It's on the other side of the window. I'm holding it by its tail. Stop. Look. Well, now the window screen's broken. Guess I'm never opening the window again. Bro, are you serious? Why did you do that? Her ass would run right away. She would die out there. I don't know why she thinks that it's sweet. She would die out there. She can't eat shit. Look. The cat tried to break through the cat was broken through the window. I had to hold it by its tail. This was literally just now. Look, it's on the other side of the screen. It's literally about to jump out of the window. And I was holding it by its tail. When I tried to pull it back in, like it literally jumped. Like I had to like hold it up by its fucking. I don't know why I did that. It's so ridiculous, dude. That just happened literally just now. Like that literally just happened. I looked, I was like, wait. Wait, what's going on? And then I was like, yeah, the cat's trying to jump out of the window, dude. Now there's fucking cat hair all over my desk. Great. Thanks, guys. I hate these cats, dude. Hate them. Medvedev? Who remembers Medvedev versus Djokovic? This nigga drunk? Medvedev versus Nick Kyrgios. Okay, come on. Quality's unavailable to change? Turn my fucking Wi-Fi off, dude. Even quality's unavailable. There's no better quality. I can't raise the quality. Are you stupid? Are you stupid or dumb? Okay, I can't change the quality, I guess. Okay, I can't even see the ball, dude. Did he just serve underhand? Okay, Federer would put this kid in a coffin. Return speed 138 kilometers per hour. Bro, this nigga's not real. What am I watching? Is that the ATP Tour, bro? I don't believe it. It has to be like a scrimmage. Okay, Medvedev's not even playing seriously. If Medvedev was playing seriously, dude, there's no way. Dude, he made it to... He, like, was winning games against Djokovic. Like, he's a good tennis player. Bro, what was the serve speed there? Like 20 kilometers per hour? Bro, what is Medvedev doing? He has to be trolling. Bro, what is going on? This has to be... This is all because they don't like clay courts. What is he doing? So you're telling me this is like a real tennis match? I don't believe it. I actually don't believe it. I can't watch that game anymore.
Which one were we on? Jujutsu? Okay. Alright, let me lock. Oh, I can't even say that. Y'all niggas are glazers, bro. How much is 300 kilograms? What's heavier, a kilogram of steel or a kilogram of feathers? Hello? Yeah, it is. Oh, it's not on. It's not like turning on at all. Oh, then it's too hot. Yeah, it does that. Yeah, it's where you unplug it for 10 minutes. You unplug it from the thing. Yeah. 93 only. No. Where do you get octane booster? Dude, it literally can only take 93. Just go to Costco. Just go to Costco. From North Liberty, it's 10 minutes. Costco is 93. Or you can go on the, you know, the website, 93 map or whatever. Yeah. So yeah. Oh wait, I forgot to tell him. Whatever. Okay, let me figure this out. Okay. Tea ice is gonna be, its initial is gonna be there's cat hair everywhere. Pressing up. We're going up. Where's my lint roller? I'm gonna just take everything off my mouse pad. Oh wait, I actually did need to go. I need to go to the bathroom though.
Yeah, boy. It's 2:57. Yo, why you jumping around, bro? I need to stretch my legs, bro. I've been sitting for like 10 minutes. Ooh, this song's fire. What's up, George Phillips? It sounds cocky. What are you talking about? Alright, bet. Alright, am I doing this right or no, dude? Yeah, girl. You want me for that money? You won't wear, girl. Alright, let me log in. Get the fuck out. Okay, so. Wait, let me think here. Oh, let me see if the thing is still. Yeah, the desk is no longer warped. Did the screws come loose from natural? No, they didn't. Oh, a little bit actually. Except I'm off the palm of my stomach. I bet. What did you say? You said something in the Discord or something? No. Alright, let me lock in. So let's think about this. So what all is cold and what all is hot? I think everything is cold besides for the calorimeter. Or besides for the... Yeah, because if you think about it, you could put everything on one side of the equation and just do TF minus TI. Oh, wait. Wait, what's going on there? So they're all mixed at the same time. Melt ice here. Yeah. Yeah, so it's heat
heat plus heat, because these are temperature increase plus temperature increase equals temperature decrease plus temperature decrease. But how's the water's temperature decreasing? Whatever. Let's solve this equation. Let's solve this. Okay, the mass of the ice is 10 grams. LF is 334 joules per gram. Plus mass of the ice is 10 grams times 4.187 delta TI is going to be TF minus 0 degrees Celsius. The mass of the water is 50 grams. 4.187 This is 20 minus TF. Plus okay. So we have joules. Let's do this math. But it's minus 0. Okay. 41.87 plus 209.35
plus 96.75. $4187 plus 24187.5 minus 3340. Yeah. Gosh damn it. I think that's what it is. Where's my notes? Oh, here. Yeah, MCLNTF over TI. Yeah, it is. The sea of ice is 2.09. TI is what, 0 degrees Celsius? What? Oh, Kelvin. I always do that. Oh.
latent fusion is Wait, I need to read the question first so I can at least think about it while I'm spinning. You know, if you spin once the other direction, you won't be dizzy anymore. Determine the total entropy change for the 50 grams of water to reach the final temperature of the system. Total entropy change, that's just going to be MC ln TF over TI. Wait, of the water? Hold on. For the 50 grams of water to reach the final temperature of the system. Yeah, it's just going to be MC ln. Because there's no components of the water. The water's entropy, same with the copper's entropy. The copper's entropy and the water's entropy are just gonna be like pretty stagnant. Not stagnant, simple to calculate, intuitive. Because the ice, you have to do the melt and the Oh my gosh, guys, wait, I'm really stupid here. The specific heat, it's no longer ice, it's water. This is 4.187. What an idiot. Oh, fuck. What was the temperature again? 345.09 over 273.15. Okay. Determine the total entropy change for the 50 grams of water. Wait, C is in grams per degrees degrees? Yeah, it is. The original temperature of the water is 20, right? Yeah, 20. So we get 293.15 over, what was the final temperature? 71.9. So 345.09. Oh, this is 0.05. This is supposed to be 0.05. Oh, let's redo that then. It's the same. It's literally the exact same answer. It doesn't change anything. 50 times 4.187. Well, sometimes the natural log like exacerbates it. Yeah, because it decreases. Oh, I'm an idiot. This is positive. Because this is the opposite. TF is 345.05. This is 293.15. Right, if we switch them, it should just be 345.05 over 293.15. 34.12, yeah. This one will be negative 250 grams times 0.387 joules per gram degree Kelvin times natural log of 345.05 There we go. What was the initial temperature? 250. Oh, this is the final temperature. $150 times 0.387 times the natural log, the fraction of 345.05 over 523.15. That's it. This is done. Alright, I'm gonna redo that on paper, but later. Let me forget it. Alright, I just forgot it. I'm just trolling. Alright, let me do the how many pages do... Oh my gosh. Oh my gosh. Okay. But my hands are infinitely sweaty. The sweat on my hands, it diverges. The rate of perspiration diverges in my hands. Alright, buddy. Wait, what was I gonna do? Oh, I was gonna change into some shorts because I can't even stop perspiring. Okay, I got my shorts. Don't ask why I'm out of breath. My dog will let me know when my packages are here. Hey, let me tell him. Alright, they're gonna let me know. I just asked them. They're gonna let me know when my package is in. No, they would be going crazy. Those are just false alarms. They're trying to trick me. You'll know when my packages are here. It'll be bad. Oh, Travis Davis. Hello. I'm good, how are you? Okay. So, my dogs will let me know when my packages are here. Let me study for this exam. Oh, why don't I open? I'm so stupid. Why don't I open the answers to the worksheet here? Part 2, study guide solution. Okay, so I'm gonna work. So I might leave at around 6 o'clock and then come back. So in like 2 hours and 15 minutes. But I would come back. I don't know if I'd end stream. I mean, it would probably be like an hour. I would be gone for like an hour. I don't know if I'm gonna end stream or not. We'll just cross that bridge when we get there, buddy. Buddy. All right, buddy. All right, let me do this thing and get some water. Oh, there's water. Oh my God. What the fuck is an avocado number? No. I think the number is this one. I think this is the number. I think that's what it's, Avocado's number? Yeah, that is it. No. No. It would be like you just have protons and neutrons and electrons. Well, no, I guess electrons as well, yeah. You can't have less than one molecule. Yeah, monoatomic is the smallest, right? Monoatomic, is that what it's called? Monoatomic? I mean, that's what makes sense. Single atom. Dude, are you retarded? Rebooted? That was a nasty cough. I've not used Jekyll, whatever the hell that is. Yeah, that's what I thought. No, I didn't. I wasn't even gonna say that. I wasn't even gonna say that. I wasn't gonna say the R word. I would never use that word, like, genuinely. It's disrespectful and insensitive. Okay, good. Yeah, it's good. The molar mass of gold is blank per mole of the gold, and a ring has a mass of 3 grams. Determine the number of moles of gold present in the ring. Number of moles is going to equal N. We have grams per mole, so that has to be in the denominator. That's easy, because you can tell by the units. Yeah. Estimate the number of gold atoms inside the ring. Oh, you'll need to look up the atomic number for gold, AU, to find the number of electrons. The number of electrons in gold is 14. No, I'm just making shit up. How many electrons in one gold atom? $79. Oh, you have to put this. Oh, I didn't put my units, chat. I'm an idiot. Oh my gosh, why do I keep leaking? How many pages is this? Oh great, it's only 1,000. That's fine. I'll get to it. Okay, let's actually get to work then. The chemical formula for water is H2O. The molar mass of hydrogen is about 1 gram per mole, and the molar mass for oxygen is 16 grams per mole. Estimate the number of water molecules that will be present in 1 gallon of water. So each atom, or each molecule of water is going to be 2 times 16. Wait, 2 plus 16. Molar mass of water. Yeah, 18. That's what I thought. Estimate the number of water molecules that will be present in 1 gallon of water. 1 gallon. Okay. One gram per milliliters. So 3.78 times 1,000. Wait, 1 gram equals 1 milliliter? Yeah, 1 gram equals 1 milliliter. So 3780 grams. So we need 3780. Yeah, boy. I've heard that word before. But my hands are still infinite sweat. Where's the air conditioning? Do we touch it? Do you think my dad's gonna teleport down here if I change the thermostat? It's probably something ridiculous, dude. My family's weird. It's probably like 78. Like I could die at 78 degrees Fahrenheit. The house is at 73 degrees Fahrenheit, but it's set to 20 degrees Celsius. So I guess it's a good setting, but the reason the air conditioning is not working is because the storage room is open for the cats, but the storage room is like 2,000 square feet. Wait. Yeah, it might be 2,000 square feet, but it's not air conditioned. No, it's probably less than 2,000 square feet, but it's not air conditioned. So all the air conditioned air is just going in there. Well, actually the heat from there is being transferred into this room that's air conditioned. So it decreases the efficiency of our air conditioning. It's so nuts. I wish it was 20 degrees Celsius in here. And also the sun is not helping. I'm gonna die. Let me do jumping jacks. Okay. I don't know what's wrong with me. Okay, 600 billion. 600 billion trillion, bro? What is he talking about? Okay, how many atoms will be removed? What fraction will be removed is 1 billion trillion. Okay, 1 billion 1 billion, trillion, 100,000, million, billion, trillion. How many is... One, two, three, four. Not significant. What? Oh, 600 billion trillion. 600 billion trillion. I did 1 billion trillion. Oh, I can just do this times 600. Yeah. If you don't believe that I got the right answer, here you go. Look, you see it? Fuck. You see it? Yeah. I mean, shit's easy. No, I'm kidding. Okay, here we go. This is more like it. The study of ideal gases can involve both versions of the ideal gas law shown below. State the identity and the SI unit of terms listed below. Include any common unit conversions that are used to go from SI units into other unit systems. One atmosphere is 101,300 pascals, or I don't know how many psi. Are you high? 1 meter cubed is like 1,000 liters or something. It's it's power of 10. It's 1,000. It is 1,000 liters. Yeah. 1 million milliliters. 1,000,000. To gallons. Are you high, dude? So the answer's not even on. Okay, atmosphere to psi is 14.7 or 760 millimeter hydrogen gravities. Gallons. There's nothing on here about gallons because it's never been used ever in the history of any class. Bro, I don't know how many liters are in a gallon. Are you high? Okay, let's do the SI units of each one of these. So we want pascals, meters cubes, and then we get joules. T, we want this to be in Kelvin. N, we want this to be in moles. Capital N, I don't even know what the fuck capital N is. It's a constant, no? I don't even know what capital N is, dude. Oh, I remember, be quiet. Number of molecules. Number of molecules. So this is in items. Or like molecules or atoms. R. Everyone knows R. R's is joules per gram, well, kilogram. Wait, no, R is joules per mole Kelvin. Obviously, because you need these to cancel. Well, all of these to cancel. Oh, wait, those don't cancel. Oh, because you need them to equal joules on both sides. Temperature, okay. K is a constant, and it's joules per Kelvin. You can figure all that stuff out though, because you know N doesn't have a thing. You want it to be joules, and you have temperature, which is Kelvin. So this is like / none. It says no SI units. I don't think the answers for this is on here. Oh, it is. Oh, you're supposed to give the value. 8.314. I have that memorized. I don't have K memorized. 1.38 times 10 to the negative 23. Yeah, what the fuck is this gallon shit, bro? 264.55. I'm just gonna use 250. If they ask me on the exam for gallons, I'm using 250. And he's gonna be like, you know what? It's pretty close. I'm not using no fucking 264.55. Well, now that I said it out loud, I just memorized it, so. Look, I don't even need to see it. What was the number? 112.3? What is the value of R used in the standard chemistry units of atmosphere liters per mole Kelvin? Using the factor labeled to convert the SI unit of joules per mole Kelvin into the chemistry unit of atmosphere liters. I could cry right now. So if it's in the numerator, to change it you have to divide. What is the value? So it's going to be 8.314 divided by, so this is Pascal meters, so this is 8.314 Pascal meters cubed per mole Kelvin, which is going to equal, so we have to do this is what the lecturer does. He draws this shit. He does pascals here, moles here, degrees Kelvin. These just stay the same. And then we have meters cubed here. And to convert the pascals, we got to do 101,300. And then to convert the meters cubed, we got to divide by 1,000. Oh wait, you times by 1,000. And then this is times 1,000, I think. Because 1 meter cubed is worth 1,000 milliliters, yeah. So you do 8.314 divided by 101,300 times 1,000. 0.082 atmosphere liters. Is this right? Doesn't even fucking tell you. Ew, dude, I'm actually really good at this shit. I'm him. Dude, what is this, 1 billion pages long? Look, I'm going back to downward facing dog. Hey, yo, what's he talking about? Am I going crazy? No. No. What the fuck are you talking about, dude? Okay, well, I need to play good music. I can't even think. Bro, where the fuck is my package? I don't know what song this is, but I'll just play it temporarily. I want to watch YouTube, so I'm about to watch YouTube. If it says tomorrow, I'm... Oh. Look at all those clothes, bro. I should have just saved it to downloads. I need to send it to myself on Discord. It's fucking crazy, dude. I have to go get these boxes. 400 pounds worth of clothes. Okay, I'm gonna be dead ass. I don't think I'm capable of bringing, I don't think I'm capable of bringing all those boxes down by myself. I'll have to wait till my brother gets home because it's just, there's 400 pounds of clothes. I think it's more than that. Those boxes were heavy as shit. Bro, that was crazy. And so many boxes. This kid didn't respond to my message, so I'm going to the ice rink. I'm not going to play tennis. So I have about an hour and 45 minutes till I'm leaving. I need my brother to come home so that I can do the thing. And I also want to turn on a YouTube video while I do my work. Oh, Tyler's just down. He's down the street. Oh, no, he's not. Bro, he's at Casey's. You can't put Casey's gas in my car. I'm gonna have to, drain my fuel. Can you do that? Can you do that? From carburetor. Are you hot, dude? From car. Bro, I'm gonna set my house on fire. There's gonna be 12 gallons. There's gonna be 12 gallons of gas in my driveway. Okay. Oh, let me put on a YouTube video so I can watch it while I do work. Maybe not a YouTube video, maybe something else. It feels bad for my neck to be looking down though. I'm like this, like looking at my iPad. Is there a way that I could not look down, do you think? Are you bored yet? Nah, dude, I'm actually, I'm sad. I'm sad because I have to study. Are you 2K ELO chess? Maybe over the board I am 2K ELO chess. Online I'm only a 1700. Are you a hockey player? So I guess I am 2K ELO chess. Are you a Division 1 hockey player? Well, not NCAA D1. The team I might play for my university next year. I couldn't play last season because I was injured. But next season I can play, and they're Division 1, but ACHA. They're not NCAA. So yeah. I answered, bro. I said no. I didn't. The code for my website's on my GitHub. Like, you can go look at it. From my website, you can go to my GitHub and see the code for it. I think there's like a thing for on my website. Like, if you go to projects. Yeah, this website, and you can click on the GitHub, and you can see all the code for the website. This is the main file. Well, not really, because there's a lot of JavaScript that goes into it, but the JavaScript's in this file. The old JS is, I can just delete that, honestly. But all the JavaScript's in this file. Which actually doesn't look that deep on GitHub. Bro, on Vim, it's like I'm scrolling for hours. 582 lines of No, the real problem though is the CSS. The real problem is the CSS. Although I did clean it up, I'm pretty sure it's still well over 1,000 lines. Yeah. Which makes no sense. It's CSS. Bro, it's impossible to find anything on there. It's so stupid. Yeah. Dude, this cat just... No, I just lint rolled my mouse pad. Like, I just did it. Like, an hour ago. I just did it an hour ago. I wish I played D1 hockey, bro. But if I played D1 hockey, then I would not be doing anything that I'm doing today. I would still be a hockey player like I was back in the day. No school, bro. I mean, like, there is school, but, like, it's... Wait. No, it's chill. It doesn't... You can ask as many times as you want. I don't care. I just made a website. Can I see the website that you made? You have to send... If you send the link, you have to, like, make it not a link. You know what I mean? Like, you have to add spaces, because it'll... If it recognizes a link, it'll just block it. Like, if you have just a bunch of words and periods, it won't block it. So just make sure you, like, format it correctly. Or you can send it to the Discord. If you're in the Discord, send it to the Discord, because that's easier. Send the link to the main chat in the Discord. I want to see your website. Because I actually need some inspo. Or not like inspo, but like I need... I just want to see it so I can maybe use some of your code. Or like use... Because your blog... Dude, my blog was so complicated. The JavaScript behind my blog was so stupid, I think. Well, actually, it wasn't really that complicated, but... It took a lot of an iteration. You're getting distracted. You got dreams to chase, not people to impress. Log in. Dude, he's gonna send me his website, and then I'm gonna be able to use his website to help my website. Who's here, dude? Who's here, dude? I didn't get a notification. It didn't say... With a push pin emoji, arrived at home. Oh, it's my sister. My brother's gonna be here hopefully soon. Oh, okay. I get it. But are you the guy who studied 6 hours or 9 hours for CS 173? I am. I am the guy who studied 9 hours for CS 173. Bro, can I use your code? Sure. You can use whatever you want. You can copy and paste it if you want. I would advise you to not do that though, because then it looks really unprofessional if two people have the exact same website. Maybe I should copyright my website. No, I shouldn't. I mean, I don't know why you wouldn't want to use my website anyways. There's a lot better, like, real websites that are made for public use, like templates. Mine has a bunch of bugs, lacks a lot of functionality, and honestly, if you're not me, you're probably not going to be able to read the code coherently. Like, you're not going to know what the hell is going on, because I don't even know what's going on, and I'm the one who wrote the code. Are you doing 225 next semester? I am. Heard that class is light. Alright, bet boy. Why does this kid speak like that? I bet. Wait, would I get like banned for streaming South Park? Yeah, I would actually. I know I would. 225 is goated and super free. I'm a CA for 341. I'm neither, dude. I'm just physics. I'm not taking 341 actually. I could, but it's not required for me. I'm just physics. I'm doing the computational physics track, so I have to take like 225, 173, 128, 124, all those classes, and then a couple higher level CS classes. But I'm also doing a master's in CS, so I'll have to do a bunch of classes for that too. Not 341 though. Which is good. Yeah, CS plus physics is only for incoming. Old heads like me can't get grandfathered in. If you're getting a master's in CS, you need 341. It's legit the best class ever. I'll look at it. I mean, I did enjoy discrete, and it wasn't too difficult, so we'll see if I do 341. I heard it's like just much more difficult than discrete though. I mean, just look at like the grade disparity. Wait, am I thinking of 341? Is 341 the right class I'm thinking of? Wait, I don't know if 341... Wait, what's the class that's the next level from... What's the next class, like next from CS 173? Is it 341? Is 341 the next from 173? I'm not taking 233. I heard 233 is just like a joke of a class. $357. What is 357? Numerical methods. Oh, I have to take numerical methods. I'm on the wrong Google account, so let's get over here. I have to take numerical methods, I think. CS what? 233? No. What's numerical methods? 357? 357, yeah, I think I have to. Yeah, 357. Taking it my junior fall. This is all I need to graduate before my senior year. I might take classes my junior summer, but it depends on if I want to graduate in May or not. I might end up taking classes all throughout my senior year, but probably won't do that, honestly. Is this Ubuntu? Yes, it is. Do you know what a break is? I think I've heard of it. Is it, what language? You should give up everything and flee the world to become a monk. 233 is super interesting. Yeah, I probably won't take it. It seems like it wouldn't be too interested to me. Can you scroll up? Let me double check your schedule. Okay. This is the semester I just had. This is what I'm doing over the summer, and then next semester, this used to be physics 212 here, but since I'm taking it literally like right as we speak, I have a free slot open here to add another class. Why physics plus CS and not math plus CS? I don't know. If I was physics plus CS, I could answer that question for you. But I guess maybe you're thinking like physics plus CS in general and not like the specific major for my university. I enjoy physics and I somewhat enjoy computer science, but more so I enjoy machine learning, and that's a subset of computer science, so I'm honestly forced into going into it, but I do enjoy computer science as well. 225, 220, 257, stat 400 are all free. I think 225 is hard though, should be doable. No, I heard 225 is like kind of hard, but it's a 2 credit hour course, so they can't like assign too much work, but the exams are hard. It's like a bunch of Taylor series and stuff, Calc 2 stuff. It's really stupid. Was Calc 2 hard? For me, Calc 2 was very, very easy. I averaged like a 98 on exams, besides for the final. 225, 257. Oh yeah. Well, I actually heard 257 is hard. I know stat 400 and 225 are going to be pretty easy, but I heard 257 this year was actually pretty difficult. I do have a really good professor because I'm a James Scholar, so I got like the good professors. But I have some friends in 257. They said it wasn't that good this year. Calc 2 is the hardest calc, but it's not hard. I thought Calc 1 was harder than Calc 2. Yeah, 257 was the freest A of your life. Yeah, they changed up the course a lot, though. I've heard. I mean, I literally haven't taken the course, so I have no idea. But that's what my friend said. My friend said that they changed up the course a lot and that a lot of people were struggling. And from my experience asking people, a lot of people got Bs. Like a lot of the straight A students that I knew got Bs, so it was a little bit alarming. But I mean, honestly, if they're getting Bs, then I should have no problem getting an A in the class. But I already know a little bit of linear algebra, so maybe that'll boost me a little bit. But I'm not going to be taking 13 credit hours. There's no way. I'm probably going to fill this with research. It's like CS 390 something. Or no. Wait, what number do you guys do? I was either going to do CS research or physics research. I forgot. There's like a class called student research. Okay, why is there like a billion students research? Okay, well, it's like oh no, it's topic. That's what they call it, topic. Topic. No. Wait, no, they don't call it topics. What do they call it? What does the CS department call it? I don't know what the CS department calls it. I'm trying to think. It's some 90. It's a 90, so we can just look at all the 90s. I think it might be, for undergrads, it might be 290, honestly. 296 is honors course. I checked 390, that wasn't anything. Yeah, I don't really remember what number it was. They're usually 99, but I don't see it. Special topics? No, that's not it. Research? No. Oh, you know what? It's not going to be on grade disparity. Yeah, what am I talking about? It's not on grade disparity. That's why. Yeah. No, yeah. It's not on grade disparity, but you know what I'm talking about. It can be up to 4 credit hours, depending on how much work you do. So I think I'm gonna try to get about 4 credit hours. I also have a co-op opportunity, but I didn't really think co-op would be the best decision. Because I want to learn first, right, before I go into working. So I prioritize learning over working. Even though it's in machine learning, so it's definitely what I want to do, and maybe I'd be able to learn there, but we'll see. I'll have to figure it out. Yeah, if you want to learn machine learning, you need more theoretical CS. Yeah, that's true. Can you get off my mouse pad, kitty? Kitty cat? Thanks. Yeah. I mean, for the building blocks of machine learning, really only need like 257, Calc 3, and obviously all the specialized machine learning classes that we have on campus, which is a lot, and then like 225 and stuff. Hold on. No, I don't want Chipotle. I'm supplementing Stat 400 for CS361. No, I don't want Chipotle, not right now. I'll maybe get it after I skate. Yeah, I'm taking Stat 400. Since I'm not CS, I can take Stat 400 instead of 361. But that's what my CS advisor said. But I've heard mixed things. Oh, you took it last semester. You took 361 last semester. I heard it was terrible. Yeah, I heard it was terrible. Have you done linear algebra? I've read books about linear algebra, but I haven't formally done it through institution, not yet. For 40% curve is crazy. No, that's nuts. 361. I've heard so many bad things about that class, and that's honestly one of the main reasons I stuck. Well, not really. I really did want to take 361 because I thought 361 would be better than 400, but my advisor just said it wasn't worth it. But now that I am not taking 212 next semester, I might take 361. Yeah, 361 seems more fun than Stat 400 as well. Especially because how was the project at the end? I heard there's like a machine learning project at the end. It's not like hella coding or anything. Yeah, I know. It's pretty similar to Stat 400 in that respect. You can show me yours. Is that allowed? Like a demo? Not the code, but like a demo maybe? Just basic linear regression algorithms? Wait, are you serious? I've already coded linear regression algorithms. I did that for my project for CS 128 honors. But maybe it's more complicated than what I did. A lot of people were complaining, and I was just wondering, like, do these people not have the internet? Because a lot of the questions you're being asked, there's a bunch of references on the internet to help you get to the answer and help you learn how to do it. You don't have to solely rely on like what the course provides you. Because I was seeing on Reddit, like people were saying they had problems with their code, and I was like literally you can Google what the people were saying in Reddit, and a Stack Overflow link would be the first link, and it would just completely solve the problem that they said was the reason they got a bad grade in the course. So it's like, come on. At what point is Googling like gonna become a skill? I took CS 328 at MIT and I met Jeff Bezos. Manbir Singh is him. He's telling the truth too, because he's a mod. Ooh, that sounds really appealing to me. Yeah, I'll really have to look at CS 361. I mean, I have to get an A in Physics 212 for me to even want to transfer, like submit the transcript to UIUC. So if I get an A in this summer class, which I think I probably will, then I'll definitely switch into CS 361 since I'm not taking 212. I was thinking Stat 400 because I heard it was just objectively easier. Might have to lock in on the exams. Dude, if I'm in 13 credit hours, are you kidding me? I always lock in on exams anyways. Pulling like 11-hour study sessions. And there's hella extra credit. Yeah, it's with like all the classes. CS 225, but 128 didn't even have like extra credit opportunities. And the extra credit was enough to bring me over a 100% in the class. It's crazy. The CS classes, they like really, worst class ever? What? I finished with like a 102.3 in the class. But that's because they gave extra credit. 225 equals best class ever? Yeah, I heard 225 is much better than 128. Well, you might not have had Professor Nowak, who the same professor that I had. That might be why you had a bad experience. You had Nowak. Oh shit. Maybe it was because he was early. It was early when he just transferred here. I don't know. The class is really well structured now, but even the TAs for 128 said that 225 is still better structured, and there's a lot more support with 225. So like I was literally in office hours doing one of the MPs, and the kid was like, yeah, like 225 is just so much better. It's much easier to get an A in 225. You think he's so L, bro? Have you had Jeffrey Challen? I haven't had one like long conversation with Jeffrey Challen. It's like I'll email him and then instantly he responds, tell me to drop the class. No matter what I email him. Like, it doesn't matter what I say. I could be like, oh, I have a 99% in the class. Can I get curved to a 100? And he'll tell me to drop the class. That's what he says. He's like, I would dox the emails, but I'm not. You hated the intro CS classes? Yeah, I mean, honestly, they're not very well structured. 124, like I just grinded the practice quizzes and then copy and paste from my memory onto the quizzes. But I learned a lot. I ended up learning a lot because it helped me in 128. 128, the best MP was the last one by far with breadth first search. My calc final got curved. Dude only counted the highest grade out of all midterms. What the F, bro? What the hell? That's such a W. Wait, what? He only counted the highest grade? So what was I would have just not taken any. Would have got like 100 on the first one and just not taken any more for the rest of the semester. Swap to CS plus physics? It's not possible. Only incoming freshmen are allowed into those programs. CS plus physics and CS plus bioengineering. I would be more interested in CS plus bioengineering than CS plus physics, honestly. But I can't switch, which is fine. I'm really content with getting a physics degree. And I'm getting a master's in CS and then a PhD in machine learning and neuroscience. So I'll be able to learn all this stuff anyways. Yo, what is a mole? On God, I have AP Chem tomorrow. A mole is just like how many molecules are in a substance. Or like how many clumps of molecules, I guess you would say, because you have to use the avocado number. I don't really know what it's called. It's called like the agravado. I say avocado number. Yeah, you can't. The new CS pluses can only be transferred in for 2024 and newer classes, like people who graduate in 2028 and later. Because my interest will change over time. I'm definitely gonna stick to the master's and PhD. but they may change. My master's and PhD may change. Like what I write my master's thesis might change, or what I choose. Because PhD, or at least the program that I want to go to, you kind of get to like choose. You get to choose. Well, I'm not going into like software engineering, so I don't really care what like the pay for software engineers is, because that's not what I want to do. Yeah, I'm gonna get my master's, because UIUC said they would pay for my master's, and then what's it called? I want to apply for the scholarship that'll pay for my PhD, so it's free school. So I mean, who could turn that down? Where do you want to go for grad school? I want to do my master's at Illinois, and then I want to be a Rhodes Scholar and do my PhD at Oxford. I might not even have a choice whether I do a PhD or not, because as of right now, the only 3 schools that I'm applying to for PhD is the Rhodes Scholar for Oxford, MIT, and UC Berkeley. Those are literally the only 3 schools I'll apply to for a PhD. I might end up not getting into any of them and having to work after my master's degree, which is completely fine with me, but you're gonna get a 5? Good, bro. You should get a 5, because then you don't have to take Gen Chem in college, which is really clutch. You fuck with the Guts profile picture? I know, Guts is him. What's up, Muhammad? I'm probably going to do 2 years of job, then come back to UIUCs to do a master's for funsies. Yeah, that's a good idea. What's your dream job? My dream job is to use the knowledge that I learn in school to solve real world problems. And like, I know that sounds like pretty cliche, and like it sounds like that's a ChatGPT answer, but genuinely, like, that's what I want to do. I don't know like what specific. I mean, I want to go, as of right now, I want to go into machine learning, and I think I want to try to solve, like, maybe work on AGI, depending. I don't really like large language models, though, and I was really thinking about medicine and machine learning. That was really interesting to me, because a lot of the problems and errors that we have in our medical system can be solved with complex machine learning models, and I think it would be great to improve the efficiency of, like, how well we treat patients, because then more people get to live and more people get to live better lives. So it's great. I think that's a great thing to do, and that's definitely what, like, something that I would want to do. But there's a bunch of things that I would want to do. What's your dream car? A Porsche GT3 RS. If you say anything other than that, you're not him. I'm currently a grade 12 student stuck between choosing CS, computer engineer, and a BBA degree. I don't know what a BBA degree. The choice between CS and computer engineering is a little bit like, they're two very similar things. So whether you choose one or the other will not have, like, really any direct impact on your like outcomes after college, but your interests definitely will sway whether you want to do CS or computer engineering. You have to realize that computer engineering is a lot of, like, if you want to go into software engineering, you shouldn't get a computer engineering job. Like, you just straight up. If you want to become a computer programmer, don't go to computer engineering, because when you get to school and you see, like, my roommate's a computer engineer, and you see the classes that you have to take, the intro classes, they're making you take circuit classes, they're making you take abstract electricity and magnetism classes, they're making you take, like, these crazy easy, well, they can do SWE, but it's useless to get it, well, not useless, but you're overcomplicating your path to becoming a software engineer. And if you don't enjoy the things that you're putting in your path, then you're not going to have as good of a time. If you enjoy computer engineering and you enjoy low-level architecture stuff and electrical stuff and circuitry, then yes, computer engineering is what you want to do over computer science. But if you want to become a software engineer and you're not going to enjoy the hurdles that you put in front of yourself choosing the ECE degree over computer science, then there's no point to do computer engineering. And BBA is business. I I wouldn't personally do business. I know a lot of people who do business and are very successful, but that stuff genuinely does not interest me, so I don't really have that much of an input on that. My CS teacher is very boring and I feel like I hate the class, and personally I like hardware side more. Oh yeah, you sound like a computer engineer for sure. Alright, good night, bro. 3:30 a.m. is crazy. Honestly, more people I know in EC have sweet jobs than my CS friends. Yeah, that ends up happening. But I think that's kind of because UIUC, it's like if you don't get into CS, you go to the EC department. So I think a lot of the people are just misplaced computer scientists, you know? Does it really matter at which school I get my degree from? It does to an extent. I would say for internships, it matters a little bit more over like after graduation. After graduation, it really depends on like who you are as a person and what you have behind your name, like what projects you have or what proof you have that you have these skills. Is more important than like necessarily like what school you went to. But for internships, it might have like a slight impact. So I don't think overall in your life it shouldn't really make a difference where you go to school. As long as you're getting quality education and you use that education in your job, then you'll be fine. Yeah, and obviously if you go to a top 5 school, then you're obviously receiving a really good education by objective standards. Yeah, you can be educated anywhere. I know people who go to community college and end up with great lives. Yeah, it might be more difficult to succeed from community college opposed to getting a bachelor's degree from a top 5 school, but it's still very possible. Do you fear working a 9 to 5, or are you planning to just embrace it? I mean, 9 to 5 sounds pretty boring. I don't want to work so few hours. Good luck on your exam, thanks. Aiden, how many hours a day you have to put in to pass engineering exams, would you say? Oh, how many hours a day would you have to do to put it to pass? I would have no idea. You'd have to ask someone who's gotten like lower grades on exams, maybe closer to passing. I would have no idea. I know that the work that I put in is overkill to get an A, but that's just because I just genuinely enjoy learning and I enjoy studying, and I don't really have much else to do throughout the day. I'm having real anxiety for university because I'm graduating next year. Want to go to SWE and know basically intermediate level C++. Am I cooked? No, you shouldn't be. My school personally expects that you have no level of computer science knowledge when you arrive on campus, and they teach you all the stuff that you need to learn. So if you went to my school, you'd be completely fine. You could have never touched a computer in your life, and you would have been able to easily go through the intro classes at my school with a decent grade. Not saying you'll get an A, but you probably will get above a 3.0. How much work you put in to get an A? I would probably say honestly, it depends on the class, but I would say about 6 hours in total to study for an exam. After you already know the information and know the concepts, just 6 hours of practice and studying should get you an A. So it's really not difficult at all. You could study the day before the exam and still get an A, as long as you know the concepts before you start studying. Like if you're trying to learn everything in 6 hours and study, then like that's not possible. But if you already know all this stuff and all you have to do is study, 6 hours is completely fine. Yeah, I mean, he has a 3.8 GPA. I assume before Tim studies, he knows the stuff already. And maybe he studies for 6 hours the same day of the exam. I've had that experience as well, where I've studied only the same day of the exam and gotten a decent score. And a 3.8 GPA is pretty good, yeah. I'm from Europe, and how my country works is basically after high school, you graduate and go to university, no college. University and college are synonyms. They mean the exact same thing, at least in the context that we're using. When you graduate in the United States of America, you also usually go straight to university. There's some times where you go to community college as like an intermediary, but you generally go straight to university. Or you don't go to university at all. But you could also just not, you take gap years and stuff. You don't have to, but it's pretty standard. Where are your glasses from? They're from Warby Parker. Amina, I'm a pass if you spend 8 to 12 hours right before the exam. 82 is easy, done it for the past 4 years. It depends on how difficult the class is, but 8 to 12 hours seems like very sufficient. How do you say it, midterms? I don't know what you're talking about, but midterms are the exams that we have. You usually have midterms and a final exam. And so I've learned C++ like a little bit my freshman year, but nothing after that. And I'm taking SWE in 2025 as my major, but I got no knowledge. Yeah, you generally the department does not expect any knowledge, any pre-existing knowledge when you arrive to campus. Otherwise, that would be incredibly unfair, and everyone would have insane levels of anxiety. So you should have no problems getting through school without having pre-existing knowledge. I mean, that defeats the whole purpose of school. If you expect, I mean, maybe for a master's degree, but for a bachelor's degree, you shouldn't expect. Even if everyone had the same level of knowledge, the type of knowledge that they have might be different. So there's a bunch of different things that go into it, but it's not advantageous for the university to structure their programs where you need pre-existing knowledge to succeed. $70, I think a 70 is pretty easy. Oh my gosh, of course. If you put in enough work, of course you can pass. I mean, in college, at least, success is pretty linear to how much work you put in. I mean, there are some times where people are studying terribly, like they're putting in a lot of work, but they just are terrible at studying. But generally, if you're moderately good studier and you put in a lot of work, you are gonna receive adequate rewards. I mean, it's pretty straightforward. I thought you was a CS major. Why are you doing thermo? Thermo is required for CS majors at my school. I'm not a CS major though, I'm a physics major. And for a final, how much you study? I studied on my YouTube channel for my finals, so you can go look at those and see. I did go a little overkill because I wanted to get 100s on all my exams. I ended up not getting 100 on any of them, but I got around the 90 on all of them. What school do you go to? I go to the University of Illinois, Urbana-Champaign. Define being good at studying. That's not really a word that's like definable, and it's a phrase, not a word as well. Being good at studying means that you know how to study effectively. Depends on who you are as a person and how you learn. Yeah, for me it's just iteration. Like that's what I've found gives me the best results. But being good at studying is pretty subjective to who you are and how your brain functions. But I would say being good at studying means I can say this. It's not really a definition, but being good at studying means that you don't have to study like crazy long hours to receive the same results as like someone who studies crazy long hours, because then you're like actually genuinely good at studying, like you're better than the average person. I'm a terrible studier, I want to get better. I think being a better studier just happens over time. The more you study, the better you'll get at it. How you still got exams? I'm taking summer classes. Because the people I talk to from the degree I want to do, they all tell me that it's too difficult and blah, blah, blah. Yeah, they probably just don't put in a lot of work and then try to cram a bunch of work into a small period of time and get exhausted and burnt out or whatever, and end up not receiving the rewards that they want. And so they blame it on that the coursework is too difficult, But generally, the school would never make something too difficult for students, because then the school would be a bad school, right? That's not what their goal is. Not to make the classes as difficult as possible. The goal is that they have, like, in mind, they have what they want you to learn, and then they have various processes to get to that destination. But they think that what they want to teach you is attainable, and especially in the amount of time, which is generally like 16 weeks. So I think the people that you've spoken to maybe aren't the best people for giving you advice. I can give you advice. I've taken a handful of university classes. Last semester, I had to get a triple override to take more credit hours than were allowed by the university. They don't generally want freshmen to take 18 credit hours because they think it's too much and too much work. And I took 19 credit hours last semester. They were all technical courses, and every single class had an average GPA below or around an 85%. And I was able to get an A in all of those classes with relative ease because I put in the work. So it's all definitely easily attainable. But I mean, there's a lot of things that go into it, like mental health issues and stuff like that. Because if you do get burnt out and you do get stressed out and you do have high levels of anxiety, then you will have a different experience than I have. But I've had a pretty pleasant experience with school, and it was just mainly just you put in the work and you get it out. But it was also like, there's actually a lot of things that go into it, because a lot of people have like these interests that get in the way and conflict with how they do in school. Like if you rush a frat, or if you like to go to parties, or if you get a girlfriend maybe, and that takes up a substantial amount of time. So depending on how you balance your time and how you work mentally and how mentally stable you are, will definitely fluctuate your results. But I think overall, no matter what, it's pretty attainable to get good grades in any degree, even as an engineer. And I'm pursuing 2 degrees that are both engineering, and I think it's not too bad. Glaze. I like glazed donuts, Krispy Kreme. I haven't had glazed donuts in a long time though. You never burnt out before? No, not really. I don't really have. Oh yeah, I've just never experienced getting burnt out, but I genuinely enjoy like studying and stuff, so that stuff doesn't really get me burnt out necessarily. But I would say I kind of had some times where I was like, oh, I don't want to study right now, but it wasn't really a choice, right? Because I want to get these good grades, and I set these goals for myself, and I have things that I want to achieve, and all of those require that I get good grades. So my goals require that I get good grades. The things that I want to do in the future require that I get good grades. So I didn't really have a choice. Like right now when I'm studying, it's not because I choose to study, it's just because I kind of need to study to make sure that I stay on the path that I want to be on and that I chose to be on. So in that regard, like I don't really get burnt out, but I think also enjoying what you're doing is good. And you don't necessarily have to like specifically enjoy the thing that you're doing, but you should enjoy solving problems, right? Regardless of what they are, because that's what you're gonna want to do when you grow up, regardless of what major you are or whatever. People get paid to solve problems. If you just look at anything ever, you get paid to solve problems. So you start a business that starts solving problems for people, and that's why you get paid. You become a doctor, you solve medical problems for people, that's why you get paid. You become an engineer, you solve technical problems, and that's why you get paid. So you're gonna need to be a problem solver, and all these classes, regardless of if you enjoy the material and the content, will teach you to become a better problem solver. And I think if you kind of look at it like that, then you will start to enjoy studying more, because you're just enjoying solving problems. You're enjoying someone putting a problem in front of you and you solve it in a certain amount of time, because everything has time limits on it. And I think that's pretty rewarding and pretty enjoyable. If you think about it like that. If you think like, oh, I'm a CS major, why are they making me take physics? Then of course studying's not going to be as enjoyable. But if you take physics and you're like, wow, if you notice, physicists tend to be pretty successful because they're really, really good at solving problems, and that's a universal skill that can be applied to anything. Then you're going to study physics and you're really going to enjoy solving the problems because it's going to help you in your career and you as a person. I very much value the ability to study, to solve problems, and I think anyone who can do it to any capacity is very admirable, in my opinion. What laptop or computer do you use, and what laptop would you suggest for an upcoming college government major? I would recommend the 15-inch MacBook Air that's probably the best computer to get as a incoming freshman. If you have a little bit more money, you can get the MacBook Pro, which is better, but kind of unnecessary. The MacBook Air is plenty. I would recommend Mac 100% every day of the week. It's easier. It's the easiest to use. It's literally the best for productivity if you just look it up, and it's pretty widely used. And there's a lot of software on there that's very handy and useful. But you can get a Windows computer as well. I think the Surface Pro is pretty good. And what I use is a MacBook Pro. I have an M3 MacBook Pro, and then I have my computer, my desktop PC. I can tell you the specs if you really want. They're a little bit different because I'm not a government major. I do machine learning, so I have to have like a little bit more compute than what someone else would have. Have you already studied for this exam, and this is what you're doing on break? Yeah, I've been studying for a couple days now, doing the homework and really making sure I learn well. I do the homework, so I shouldn't be too bad. The lab was also pretty good for studying, but yeah, so I shouldn't be I'm not too worried about it. I do have to answer a little bit more questions before I'll be content, but for right now, I'm pretty chill. Switched my major from CS to information systems, but planning on going back to CS. What advice do you have? I don't know what advice I have for you. I don't know. I don't know what advice do you want to hear, and I guess I can give you that. Not many people understand the simplicity and awesomeness of Linux. Yeah, Linux is great. I'm sorry about my dogs. Mac is just nice like that. Yeah, it is. Please get off my mouse pad, kitty cat. Yep, thank you. Lenovo ThinkPad is also good. I've never personally tried it. Maybe it is good. Yeah, man, I just want to study, pass, get my workouts, eat healthy, sleep, and squeeze in an hour of anime like you. Yeah, I do all of those things, and I don't feel like, my break from studying is exercising, and exercising is really enjoyable. Eating healthy is very rewarding, and I feel better about myself from eating healthy. I sleep a lot. I usually get about 8 hours of sleep in the weekdays and up to 10 hours on the weekends sometimes maybe. And then I watch a bunch of anime. I love anime. So I'd say I live a pretty enjoyable life while being able to accomplish the things that teachers want me to accomplish. Progressing, getting it done, and grinding every day. Yeah. Amen is a bot. No, man, I'm just lost. You're not lost. You're not lost. You're where you're supposed to be. If you think the path is supposed to be a straight line, then you're going to be completely surprised when you realize that life is full of twists and turns. So you're probably not lost. You're probably just on your path, but you might be taking a right turn or a left turn or something, taking a detour. Road was closed, so you're on a detour, but you're not lost for sure. Never lost. As long as you're breathing, you're not lost, bro. Anything studying is made easier with ChatGPT. Yes, it is. I would agree with that. Oh my gosh, these dogs are really annoying. Life is like the economic cycle. I don't know what you mean by that. Maybe it is. I'm not really familiar with the economic cycle. Good luck tomorrow. Thank you. Yeah, I'm gonna stop answering chat. I'm gonna go to the bathroom real quick and then I'm gonna stop. I'm gonna go back to work when I get back. Okay, I'm going back to studying. Let's close that. Okay, so explain. Let's play some music. Some people join in the Discord. Love to see it. Explain why the absolute temperature scale be used in the ideal gas law might fail if we use Celsius or Fahrenheit. Okay, so the ideal gas law is PV equals nRT. So for example, if we're trying to solve for R, well, that's actually a constant. So if we're trying to solve for N, we have N equals PV over RT. If T is 0, then we get a division by 0. And that's only possible in Celsius or Fahrenheit. So it has to be in Kelvin, because Kelvin is greater than 0. Unless it's absolute 0, but then we wouldn't be doing this type of physics. Not with anything close to or at absolute 0. And negatives might mess it up too, because you can't have negative amount of moles. Yeah, you definitely can't have a negative amount of moles, because it's, yeah. Referring to your lecture notes, list the physical characteristics about ideal gases. Yeah, let's see the lecture notes. It's gonna be like the first page. Characteristics of ideal gases. Oh, that's really, not change. I always do that. U is proportional to T. Density of the gas must be low. Is small. Motion of the molecules is random and linear. Okay, I'll just say linear. Molecules experience elastic collision. Okay. elastic. That's pretty cool. Everything's elastic. It makes physics 1 really easy. Gas cannot be near the condensation temperature. Cannot be near condensation temperature. .300 moles of an ideal gas are at a pressure of 2 atmospheres and a temperature of 40 degrees Celsius. Determine the volume of the container needed to store this gas. Express your answers in meters cubed, gallons, and feet. Okay, feet cubed. Okay, so we have N equals 300 moles. We have pressure equals 2 atmospheres, or I think it's just times 100, 1000. 2 times 101, 300. We get 202, 600 pascals, which is really easy to work with, pascals. And temperature of 40 degrees Celsius, so T equals 313.15 degrees Kelvin. Let me make sure that's correct. Yeah, that is correct. Okay. So we can just express our answer in meters cubed first. So volume is going to be equal to 300 mole times 8.14 joules per gram. Gram or kilogram? I think it's oh, it's not either. I'm an idiot. Mole degree Kelvin times 313.15 degrees Kelvin over 202,600 pascals. So we know this is correct because we get moles cancel, Kelvin cancels, and we're gonna get, let's do the math here real quick. We get 300 times 8.14 times 313.15 divided by 202,600. Nope. Divided by 202,600. 202,612. Oh, that is the right answer. Equals 3.774 joules per Pascal. And you might be like, oh, this is not right. But what is a joule? A joule is a Newton meter. No, not a Newton meter. Well, it is a Newton meter squared, but that's not what we want in this context. A joule is a meters cubed per Pascal. So if we rewrite that, we get meters cubed per Pascal over Pascal, and that's just going to equal meters cubed, which is why we get 3.774 meters cubed. That's our answer. Express it in gallons? Yeah, no. So let's continue. I don't know how to do that. It's not on my equation sheet. It's not on my equation sheet, dude. I'm sorry. I don't know how to do it. Ask chat, maybe. Oh, should we see if 3.853 meters cubed. So imagine we rounded something a little differently. Or maybe I typed it. No. 273.15. Oh. I did 8.14 for the constant. It's 8.314. That's what it is. And then we times this by 300 divided by 202,600. Yeah, 3.8. So he wouldn't take points off for that. But it's a funny mistake to make. An ideal gas is held inside a... Fuck. I really want to... Examples. There's so much...
All your stuff is here.
What?
All your stuff is here.
I know, I brought it inside. Do you want to bring it downstairs for me?
Yeah, you have to-
It's 400 something pounds. It's probably closer to 500 pounds worth of clothes, so. It's pretty difficult. That's why I didn't bring it downstairs.
Each box is not 400 pounds.
No, in total. Each box is around 40 pounds. I think it was like 20 something kilograms. $46.1 pounds for one of the packages. I don't know which package that's for, but there's 7 packages. I think they're all about the same weight. Oh no, they're not. So it's variable what the total weight is. What? Determine the new temperature of the gas.
Yeah.
Okay.
Then I have a softball banquet. I mean, soccer. I mean, track banquet.
Okay. Okay, so n is constant. And so we solve for n equals PV over what, RT. So PV equals nRT. So n equals PV over RT. So we need to convert the pressure. So the original pressure we have here is going to be 202,600 pascals times the original volume is at 50 liters. 1 liter is 1 meter cubed is 1,000 liters. So we got to multiply 50 by 1,000. So what? That's 50,000. 1, 2, 3 meters cubed. And this is going to be over 8.314 joules per mole degree Kelvin. So we get moles goes up to the front, up to the top. Kelvin cancels out, and joules cancels out with pascals and meters cubed. T is going to be initial temperature of 60. So what is that? 333.15 degrees Kelvin. The Kelvins cancel. So yeah, we get moles, which is exactly what we want. So,
Oh, come here.
times 50 times 1,000 divided by 8.314. And then divided again by 33315. And we get n equals this large number, so I think that's probably incorrect. Oh, interesting, that's the equation they use. Okay, so I guess the moles don't stay constant. So I'm familiar with this equation as well. P1V1 over T1 equals P2V2 over T2. I use this equation a bunch on my homework. Yeah, I guess this is an easier way to solve for it, of course. So we have 333.15, which we have in the numerator, 202,600 times 50,000 equals 5. So what's that? 505, 506, 10. Fuck, I'll just do it.
What were those kids yesterday?
Yeah.
And we need to find T2.
Everybody's supposed to be good at basketball.
You were watching?
Oh yeah, 202,600 times 50, 123
I'll check yours.
over
I'll
333.15.
share yours with Mama.
That huge fucking number. So now we do 506, 500 times 40, 123 divided by
Oh,
the answer. And we get T2 equals 6.663 times 10 squared.
but this is so hard to make all this stuff. Veggies.
I didn't want to write those 3 numbers in succession. I don't think it's very good. Wait, do I need to leave now? Oh, I probably should leave about now. Actually. I thought n would be the number of moles. N is the number of moles. Current state of my NVIDIA SMI. That's crazy. When is your final? Oh no, these aren't finals. This is for a summer course I'm taking. I'm taking 11 credit hours this summer. 3.853, not 3.855. Where did I write that? 2.855. Yeah, it doesn't matter, but I can look at my calculator and see if I just wrote it wrong. No, mine says 3.855, so it's probably a rounding difference. It's not it's not anything significant. And I 100% would not get points taken off on the exam for it. It's probably from 313. He probably just did 313 instead of 313.15. And I can put that in my calculator and see. What was the number supposed to be? 3.8? 3.855. So let me find it in my calculator. 3.855. Okay, so if I get rid of this. And then we divide this by, what were we dividing it by again? Fucking hell. Two- 202,600.
Oh,
Yeah. So he didn't put the 0.15 on the end, as you can see. You get 3.853. So my answer is actually a little bit more correct than the answer key, but he tends to do that. He rounds down and up. I don't like to round. I like to keep the numbers exact. 1 cubic meter. Yeah, dude, I'm not doing that. I don't know. When do you graduate? 2026. Yeah, okay, I'm gonna end stream probably. Yeah, and I'll be in the Discord later to study when I get back. I was thinking I was going to leave the stream on while I was gone, but I really don't think that's necessary. I'm definitely not going to stream when I get back again because the stream's going to be too short. It probably will only be about 2 hours long. But I will be in the Discord study room when I study later when I get back. So goodbye.